Let us settle into a quiet, careful pace as we open the door to the origins of empiricism, not with a single flash of inspiration, but with a patient, long arc that threads together ancient observation, medieval experimentation, and a turning point in early modern thought. This is a journey not merely of ideas, but of method, of how we come to know what we think we know. What does it mean to know something, and how do we test that knowledge in the world we share? How does observation become the seed of theory, and how do our senses, fragile and fallible, lead us toward a more reliable grasp of reality? In this section, we trace origins and core principles. From Aristotle's insistence on systematic observation in biology and physics to the experimental turn under Ibn al-Haytham in optics, and then into the modern birth of empiricism with Bacon, followed by Lockean reframing and the sharpening critiques of Berkeley and Hume. We will survey the core claims, illuminate with concrete examples, and pause at points of friction where the naive trust in the senses meets stern challenges from rationalist and interpretive pressures. Along the way, we will keep an eye on how these threads continue to shape modern science, everyday inference, and the way we understand knowledge itself. The ancient roots. Observation as foundation and method in Aristotle. If we go back to the Greek world, observation was not a sideshow but a central method of inquiry. Aristotle, in his biological works and his inquiries into the natural world, treats careful observation as the indispensable first instrument of knowledge. He is often cited for his vast cataloging of birds, beasts, and their parts, but what matters here is the sensibility, an insistence that reading the natural world demands a disciplined attention to what is seen, described, and then reasoned about in light of causes and purposes. To say that nature does nothing in vain is to affirm that the world, studied closely, yields patterns and explanations when we notice the order and arrangement of living things. The phrase, "nature does nothing in vain," captures a stance. A natural order implies that the observed facts have reasons we can discover through careful description, measurement, and comparison. It is not a mystical intuition, but a call to look, record, and infer. Aristotle's observational program in biology, often embodied in the Historia Animalium and related works, is a model of how one can begin with particular observations and move toward general claims. He writes of shells and cephalopods, of invertebrates and vertebrates, of the way embryos develop, and of the functional purposes he assigns to anatomical features. The point is not that Aristotle always gets everything right, by no means, but that his intellectual posture puts observation first, and his method then moves from the particular to a broader account of nature. He notices differences and similarities, tracks variation across species, and seeks causal explanations rooted in teleology, understood in the Aristotelian sense as fitting ends within a natural order. Even when we might not share all his teleological commitments today, that readiness to learn from direct contact with the natural world remains a powerful centerpiece of empirical temperament. The world can be known because it presents itself to a careful observer. From Aristotle, we cross to a later moment when empirical practice gets resituated within a different intellectual and cultural frame. The medieval and Islamic worlds, where observation and experiment begin to take more explicit role in shaping knowledge, especially in optics and physics. Ibn al-Haytham and the formal beginnings of empirical optics around the turn of the first millennium. In the Islamic world, a figure emerges whose name, al-Haytham to the Latinized ear, marks a decisive shift. Ibn al-Haytham, known in Latin as al-Haytham, wrote a work that would become a foundational stone for the modern understanding of vision and the method by which we come to know nature through careful scrutiny. His book of optics, Kitab al-Manazir, is not merely a treatise on how light and sight work. It is a sustained argument that knowledge about physical phenomena must be grounded in observation, experiment, and a disciplined critique of accepted authorities. Anecdotes from that tradition, though small in the available texts, illuminate the spirit. Ibn al-Haytham is said to have challenged long-standing assumptions about vision by insisting that sight involves the rays of light interacting with objects and with the eye in a way that can be tested and demonstrated. He is known for performing physically grounded experiments, placing pinholes to see how light projects images, manipulating lenses and materials, and asking questions about cause and effect in light and sight that require precise observation and repeatable testing. His approach is not only empirical in the sense of collecting data. It is epistemic in the sense of demanding that claims be judged by the outcome of controlled, repeatable experiences rather than by appeal to authority or mere a priori reasoning. What does this shift accomplish? It reframes knowledge as something tested against the world, not something merely inferred from theory or tradition. The method is modest, attentive, and practical. Form a hypothesis about how light works, design an experiment that isolates a variable, observe the results with the mind trained to see what the experiment discloses, and revise. Ibn al-Haytham's procedure makes the epistemic claim explicit. The path from observation to understanding is traversed by a chain of reasoned experiments, each testable, each open to replication and scrutiny. Anecdotal touchstones about Ibn al-Haytham's experiments underscore the turn toward a method anchored in perception and demonstration. The pinhole camera, an elegant, minimal device, demonstrates that an inverted image forms on the opposite side of a tiny aperture, providing a sharp instrument to test theories about how vision operates. In experiments with light and shadow, with reflection and refraction, with the behavior of lenses, he embodies a methodological posture that would later be echoed in the experimental revolution of Europe. Test, observe, adjust, and test again. The emphasis is not only on what is true, but on how we come to know what is true. If knowledge is to be more than tradition or conjecture, it must be subject to the discipline of repeatable observation. From the medieval and Islamic worlds to the early modern revolution, Francis Bacon and the birth of inductive method, if Aristotle and Ibn al-Haytham plant the seeds of empirical habit, Francis Bacon is the mapmaker who begins to articulate a method that makes empirical procedure the core of knowledge acquisition. Bacon's project, the scientific method as inductive reasoning built on controlled observation, marks a decisive shift in how knowledge is pursued. The aim is not simply to accumulate observations, but to build reliable knowledge that generalizes beyond any one experiment, and to do so in a way that minimizes the distortions and biases that so easily creep into inquiry when we rely on memory, authority, or unexamined assumptions. Bacon's methodological program is famous for its careful diagnosis of the impediments to sound inquiry. He describes the idols that mislead the mind, the idols of the tribe, the idols of the cave, the idols of the market, and the idols of the theater. Each idol represents a habitual lens through which we misread the world, a reminder that observation is not purely passive but entangled with our cognitive structures, linguistic habits, and social contexts. His remedy is to pursue a reformulation of scientific inquiry that foregrounds systematic observation, controlled experimentation, and the construction of generalizations through robust induction. The historical anecdote often told in this regard centers on the atmosphere in which Bacon wrote. The urban academies of early modern Europe, the new literate culture fostered by the printing press, and the new appetite for reproducible knowledge that could travel beyond a single classroom or a single city. Bacon's reformulation of inquiry is inseparable from this cultural shift. The city's networks, halls, libraries, and print shops provide the infrastructure in which careful observation is collected, cross-checked, and disseminated. The empirical project becomes a social and technological practice as much as a philosophical stance. In this way, Bacon's empiricism is not merely a private exercise of mind, but a public enterprise, aimed at making knowledge portable, testable, and all the more trustworthy because it can be shared, scrutinized, and improved. Lockean empiricism, ideas arising from experience, the mind as a discharge of sensation and reflection. If Bacon gives the method, John Locke clarifies the material of that method. Ideas themselves arise from experience. In his essay concerning human understanding, Locke argues that the mind at birth is a blank slate, a tabula rasa, inscribed by sensations and reflections gathered through experience. The famous line, "No man's knowledge here can go beyond his experience," appears as a blunt, potent claim about the limits and sources of human understanding. It is not a rejection of reason but a reorientation. Reason begins with the data of the senses. The mind processes those data by reflection, combination, and association, turning simple ideas into more complex ones. The mind, after all, does not conjure knowledge ex nihilo. It builds it step by step from impressions registered through the senses. Locke's empiricism is nuanced. He distinguishes between simple ideas, those immediate outputs of sensation or reflection, color, hardness, sweetness, and complex ideas, those formed by combination, comparison, and abstraction, the idea of a triangle, a substance, or justice. These distinctions matter because they show how experience can be both the wellspring of knowledge and the crucible in which ideas are tested for coherence, clarity, and usefulness. When Locke says that knowledge begins in experience, he is not claiming that experience alone yields accidental opinions. He is claiming that experience provides the raw materials and the initial constraints within which reason can fashion stable, communicable understanding. Two robust examples illuminate Lockean empiricism in action. First, consider the everyday growth of knowledge about the natural world through observation and experiment, a project Locke regards as extending the boundaries of experience through shared inquiry. The method is not simply to observe one fact, but to observe regularly testable, repeatable phenomena, colors observed under different lighting, objects placed in different configurations, sensations cross-checked with other senses. In Lockean terms, we learn to generalize not by an a priori deduction, but by how our ideas hold up through experience, how they cohere with other ideas, and how they predict new, testable outcomes. A second example concerns the language of the mind and how we come to have ideas about external objects. Locke draws a clear line between sensation, the arrival of data through the senses, and the formation of complicated ideas through reflection and mental operation. The mind begins with impressions, but it gradually fashions ideas of substance, causation, and mathematical relationships by combining sensations and reflecting on their relations. When we say that a causal link seems to hold in the world, we are appealing to a pattern confirmed across multiple sensory encounters, tested by memory and comparison, and then generalized into a principle we can apply in new situations. The generalization, crucially, remains tethered to the reservoir of experience, what has been felt, seen, heard, tasted, touched, and reflected upon. Berkeley and Hume. The sharpening of empirical limits and the challenge to naive empiricism. If Locke gave us a robust framework for empiricism, George Berkeley and then David Hume pressed the limits, two voices that refine what it means to trust experience and how reason must function within its boundaries. Berkeley pushes the empiricist program to question the reality of the material world as a mind-independent substance. For Berkeley, to be is to be perceived. He posits a strict reliance on sensory experience, but then he transposes the ground of reality. If we cannot perceive a thing independently of perception, then the notion of matter as something existing apart from perceptual experience is, at the least, an idea that needs grounding in experience as such. The famous Latin slogan, esse percipi, encapsulates Berkeley's radical implication. The reality we know is constituted by perception, and perception itself presupposes an ongoing relationship with a perceiving mind. Berkeley's empiricism thus becomes a philosophy of perceptual dependence, a careful argument that our sensory experiences cannot be separated from the cognitive architecture that organizes them. David Hume then sharpens the empirical position in critical ways that still reverberate in contemporary debates. He asks, can we justify our beliefs about the world solely on the ground of sensory experience? Here the answer for Hume is that our most deeply ingrained beliefs about causation, induction, and the reliability of the world rest on habit, not on demonstrable logical necessity. His famous distinction between matters of fact and relations of ideas shows how experience is processed. We learn to form generalizations by observing repeated associations, yet the expectation that similar future experiences will occur in exactly the same way rests on psychological habit rather than a necessary logical guarantee. In his own phrase, reason is not the master of the passions, but the servant of the practical life shaped by those habits. He goes further to challenge the capacity of pure reason to secure the kinds of knowledge naive empiricism might promise. The inference from observed regularities to universal laws cannot rest on deductive necessity, because experience itself supplies only contingently reliable patterns, not guaranteed truths. If we put Berkeley and Hume side by side, we see an essential tension within empiricism. The more the empirical program insists on the primacy of sense experience, the more it must confront the ways perception is mediated, structured, and potentially distorted by mind. The line between what is given in sensation and what the mind constructs to give that sensation unity, coherence, and meaning becomes crucial. Hume's insistence that causal necessity cannot be derived from mere experience alone, and Berkeley's insistence that the existence of objects depends on perception, both push empirical inquiry toward the edge of what it can conclusively establish by raw data alone. These tensions are not contradictions in the strict sense. They are critical levers that encourage empiricists to explain not only what is observed, but how observation is possible, how it is interpreted, and how confident we can be that our interpretations align with something that resembles the actual world. Core principles, what empiricism claims to know, and how it claims to know it. From this historical arc emerges a compact set of core principles that empiricism holds in common, even when the exact temper of each proponent differs. Knowledge grounded in sensory experience. The bedrock claim is that what we know begins with what we can sense. Observation in its many forms, seeing, hearing, feeling, measuring, provides the raw materials from which ideas are built. The role of observation in forming ideas. Ideas arise from or are organized by experiences. Simple ideas come from direct impressions, complex ideas from reflection on those impressions, from comparison, juxtaposition, and synthesis. Inductive move from particular experiences to generalizations. The move from many singular observations to broad general rules marks the heart of empirical method. The strength of this move rests on repeatable patterns across experiences, not on a single data point or a single witness. The mind's interpretive role. Experience is not a transparent passport to knowledge. It requires the mind to interpret, to organize, to frame, and to constrain. Our beliefs about causation, regularity, and even objects' existence depend on how we process what we sense. The caution of skepticism and the scope of limits. The empiricist tradition recognizes that even strong generalizations can fail under new evidence or when the interpretive framework is questioned. The limits of experience and the potential for error require ongoing testing, revision, and openness to revision in light of new data. This core set forms a living tradition, one that is not rigid but adaptable as new technology, new experiments, and new theoretical demands press against it. It is worth pausing to consider how the core principles show up in specific, concrete contexts, how Aristotle's careful observation translates into modern data collection, or how Bacon's inductive discipline translates into the planning and execution of controlled experiments in medicine and physics. Two robust, concrete examples that anchor the story. First example, Aristotle's systematic observations in biology and zoology. In Aristotle's observational program, the living world is not a fog of anecdote but a field of regularities to be catalogued. He studies the parts of animals, their organs, their modes of reproduction, and the ways in which different species exhibit structural correspondences. His method is intricate. Careful description, careful comparison, and then an attempt to explain function and end causes. He notices, for instance, how certain features serve teleological ends, how wings appear to be for flight, how different structures align with and seem to serve particular life activities. He records what he sees in the Historia Animalium and related treatises, often drawing broad claims about natural kinds, genus, and species, and the ways in which life adapts to particular environments. The virtue here is not that Aristotle gets every detail right by modern standards, but that he models a rigorous, observational posture that does not foreclose the possibility of general laws. He embodies the empirical habit. Observe, classify, compare, and reason about why things are the way they are by tracing relations among observed features. Second example, Ibn al-Haytham's optical experiments and the critical method. The Arabic scholar's work in optics demonstrates the shift from passive acceptance of inherited theories to an active, experimental critique of claims about vision. He designs experiments with light, darkness, and the geometry of sight, isolating variables to locate where a phenomenon truly arises. The pinhole camera, the study of how images form on surfaces, the measurement of light's behavior in different media, these are not just curiosities. They are precise inquiries that aim to separate what can be known from what must be assumed. Ibn al-Haytham's emphasis on demonstration and repeatable testing becomes a model for the modern experimental mindset. A claim about how sight works is only as good as the experiment that could be rerun by another observer under similar conditions. The anecdote of his approach, an account of careful, repeatable testing, challenging established authorities, and insisting on the primacy of empirical demonstration, provides a vivid, early illustration of empiricism as a disciplined method rather than a mere collection of observations. Two contemporary counterarguments to naive empiricism in this historical frame. The rationalist challenge and the need for interpretive frameworks. No survey of empiricism's origins would be complete without acknowledging the sharp critiques that came from outside the empiricist camp, and within it as it confronted its own internal limits. Here are two robust counterarguments that illuminate how the story of empiricism developed in dialogue with other ways of thinking. The rationalist challenge. Senses can mislead, so must reason be the arbiter. Rationalist thinkers, most famously Descartes in the early modern period, argue that the senses are not a trustworthy path to knowledge on their own. No matter how much we trust gross observation, the senses can deceive, mislead, and fail. Descartes' method of radical doubt is born of this concern. If we can doubt even the reliability of sensory experience, we cannot rely on experience alone to ground knowledge. His famous move, cogito ergo sum, I think, therefore I am, sits as a counterpoint to naive empiricism by insisting that clear, distinct ideas, grasped by reason, form a more secure foundation than the flux of sensation. The Cartesian claim is not that experience is valueless. It is that experience must be grounded in the certainty of rational insight if the mind is to secure knowledge that can withstand skeptical pressure. In this sense, rationalism is not merely a rival theory. It is a corrective, urging empiricists to justify the leap from particular observations to universal conclusions by reasons that do not rest on the caprices or vagaries of sense impressions alone. There is a historically vivid dynamic here. Empiricists can seem too quick to generalize from what they have felt by experience, whereas rationalists push back by insisting that some truths must be accessible via reason alone, independent of the senses. In this tension, one sees the birth of the methodological contest that would later mature into the interplay of theory and observation in the scientific revolution. The rationalist critique does not merely reject empiricism. It pushes empiricism to articulate more robustly how imaginative inferencing, logical structure, and mathematical form can ground reliable knowledge in the face of perceptual risk. The interpretive framework critique. Experience requires interpretive schemes. The other line of critique emphasizes the role of interpretive frameworks in making sense of experience. This is a movement that prefigures later Kantian insights and more broadly concerns how we must supply the mind with categories, concepts, and structures to organize sensory data into meaningful knowledge. The empirical data we gather are not raw, pre-encoded facts waiting to be read off the world. They are signals that must be processed by the mind's pre-existing arrangements, forms of intuition, categories of understanding, and conceptual schemes that shape what counts as a stable generalization. Kant's famous formulation, "Thoughts without content are empty, intuitions without concepts are blind," offers a powerful lens here. The empirical world provides content through our senses, but that content must be structured by the mind to become knowledge of objects as such. In Kant's hands, empiricism and rationalism are not opposites locked in battle. They are complementary partners, one supplying the material experience, the other supplying the form, the organizing principles. The Kantian line signals a maturation of empiricism. It is not enough to accumulate observations if one cannot interpret them in a way that yields reliable, universal claims about objects and their connections. The critiques that stress interpretive frameworks push empiricism toward a more sophisticated account of how theories, concepts, and models organize and constrain what counts as evidence, what counts as a hypothesis, and how we infer general laws from particular cases. A broader note on contemporary threads, how the critique evolves and how the story remains relevant beyond Kant. Later developments in philosophy of science and epistemology, including the empiricist-leaning strand in the 19th and 20th centuries, keep returning to the same core questions. How can we justify generalizations from experience? How do theories frame observations? What is the nature of scientific laws if they are not simply direct readings of the world, but the organizing concepts for a network of observations? The early empiricist tradition, reformed through Kant, and later through figures like Mill and Russell, and in the long 20th century through debates about scientific realism, remains in conversation with the pragmatic, instrumentally oriented, data-driven ethos of modern science. The call to align theory with observation, to demand replicable and verifiable evidence, and to attend to the cognitive and cultural frameworks that make sense of data, these concerns are not disembodied abstractions. They are practical commitments that shape how medicine is practiced, how experiments are designed, and how policy is informed by evidence, cross-references, and tensions. How the larger ecosystem of thinkers enriches the story in tracing the origins of empiricism, we encounter a web of cross-references. The line from Aristotle's careful observation to Ibn al-Haytham's experimental optics gets reinforced by Bacon's program of induction and the later Lockean emphasis on experience. The tension with rationalist claims, Descartes' confident appeals to clear and distinct ideas, or the sense that the mind has innate structures that organize experience, points to a fundamental contrast in the period. An insistence on experience as the primary source of knowledge versus a parallel insistence on the primacy of reason as the source of knowledge's form and guarantee. We also see cross-references to the emergence of inductive reasoning as a disciplined practice. Induction, the move from particular instances to general laws, is central to the empiricist project, yet it is precisely where the rationalist challenge and the interpretive critique press for safeguards. The historical anecdote of Bacon's urban academies and the printing press illustrates a broader cultural transformation. Knowledge becomes portable, shareable, and contestable. The reading public grows, libraries expand, and the laboratory becomes a site where observations are checked against others' observations, where experiments can be replicated, and where knowledge can be revised in light of new data. The cross-referential thread to the prefiguration of the scientific method is not mere trivia. It shows how empirical practice becomes institutionalized, how the social and technological infrastructure of knowledge production enables robust generalizations to emerge from a bedrock of careful observation. Guidance for methodology, context, and early scientific practices. A script for facilitating diagrams, timelines, and primary sources as we move toward organizing a deeper exploration. It is helpful to keep in view several methodological prompts that can guide a viewer's understanding and a writer's process. Imagine a few on-screen diagrams as you listen. A timeline diagram that plots major figures and milestones. Aristotle 384–322 BCE. Ibn al-Haytham, late 10th, early 11th century. Francis Bacon, late 16th, early 17th century. John Locke, 1632–1704. George Berkeley, 1685–1753. David Hume, 1711–1776. Immanuel Kant, 1724–1804. This timeline helps anchor the historical sequence and invites viewers to notice how ideas build on each other across centuries. A diagram of the empirical method, moving from observation to hypothesis to controlled testing to generalization, with arrows showing iterative reformulation. This can be a simple flowchart. Observation leads to data, data informs hypotheses, hypotheses are tested, results confirm or refute and inform revision, generalizations are formed, and the cycle restarts as new data appear. A cross-sectional diagram of the core principles, with sensory experience at the base, interpretation above it, and generalization at the apex, showing how the mind's interpretive structures contribute to theoretical claims in an empiricist frame. A pair of primary source excerpts on screen to accompany the voiceover, including short, carefully selected quotes we can attribute to Aristotle, Bacon, Locke, Berkeley, and Hume. The excerpts should be presented clearly, with the author and work noted, and then integrated into the narration so viewers can hear how the language of the sources shapes the ideas being discussed. A visual prompt for primary source excerpts, a note on the screen to encourage students to look up the original passages, perhaps with an on-screen citation and a QR code to a public domain edition. The script should invite viewers to compare the language of the claims across centuries, to see how the questions and the phrasing shift as the method matures. A world in practice panel, where real-world applications appear, an image of a clinical trial, a lab bench with instruments, a data dashboard, so viewers can connect the historical discussion to contemporary science and policy. Including primary source excerpts and quotes to ground the discussion in the voices of the thinkers themselves, here are a few focal quotes we can weave into the narrative, each tied to its author and work. Aristotle. Nature does nothing in vain. This emblematic line signals the teleological frame that often accompanied ancient natural philosophy, but it also embodies a confidence that the natural world presents intelligible patterns and purposes to the patient observer. Francis Bacon, knowledge is power, a succinct maxim that captures the practical ambition of Bacon's project, to build, through disciplined observation and experiment, a form of knowledge that enables human beings to intervene effectively in the natural order. John Locke, no man's knowledge here can go beyond his experience. A blunt, powerful reminder of the empiricist constraint. Experience is the boundary, not a limitation to be lamented, but a compass to guide what counts as justified belief. George Berkeley, esse percipi, to be is to be perceived. The claim encapsulates a radical empiricism in which sensory experience and perception are the primary conditions of existence, inviting us to examine what reality requires of perception itself. David Hume, all our simple ideas are derived from, or are copies of, impressions, and reason is, and ought only to be the slave of the passions. And reason is, and ought only to be the slave of the passions, is another way to anchor his claim about the limits of rational justification in the absence of experiential grounding. Immanuel Kant, thoughts without content are empty, intuitions without concepts are blind. This line, while from a later point in the historical arc, helps articulate the interpretive framework critique, the point that experience needs form, structure, and conceptual content to become knowledge. We can also note by way of an approximate quotation what Ibn al-Haytham represents in this story. A paraphrase of the spirit of the Book of Optics, designed as demonstration and repeatable testing, a methodological stance that insists on empirical verification and on the careful separation of hypothesis from claimed authority. If you want direct passages, I can reference translations of his experiments and reflect on their content, but the essential point remains. The ethos of Ibn al-Haytham is an explicit step toward the experimental method. Real-world applications and modern interpretations. How empiricism informs science and everyday life. The historical arc from Aristotle through Ibn al-Haytham to Bacon and Locke looks forward to the practical infrastructure of the modern scientific method. Hypothesis, controlled experiments, measurement, replication, peer critique, and cumulative knowledge. These elements carry over into how medicine, psychology, physics, and even public policy operate in the present day. In medicine and public health, empirical methods are the core of evidence-based practice. A doctor does not rely on a single anecdote or a traditional remedy. Instead, patient care rests on the aggregation of data across many patients, the careful design of randomized controlled trials, and the ongoing evaluation of outcomes. The logic is to reduce bias, to calibrate interventions against a control, and to infer generalizable statements about the efficacy and safety of treatments from well-structured evidence. The early empiricist impulse to generalize from observation becomes the modern habit of basing decisions on systematic data, not on tradition or authority alone. In cognitive science and psychology, empirical methods also govern how we understand mind and behavior. Experimental designs, standardized measures, and statistical analysis transform subjective experience into claims that can be tested across populations and contexts. The empirical turn enables us to talk about mental processes, perception, and learning with a precision that was unimaginable in the ancient world, yet it remains anchored in the same question. How do we know what we know, and what evidence most reliably supports our conclusions? In the public sphere, empirical reasoning informs policy decisions, environmental management, and the evaluation of interventions intended to help societies. The move from isolated observation to generalizable policy recommendations depends on the same inductive logic. Accumulate relevant data, test hypotheses, consider confounding factors, replicate across contexts, and be prepared to revise beliefs when new evidence emerges. The practical aim remains the same as in Bacon's hour: to transform observation into knowledge that helps us understand and improve the world. Two more examples and two more directions for modern interpretation beyond Aristotle and Ibn al-Haytham. The empiricist tradition, over time, gives rise to broader questions about what counts as evidence, how to interpret data, and how to adjudicate competing explanations. Consider two more interpretive directions that are widely discussed today, yet traceable to earlier concerns. First, the move toward the social and methodological dimensions of evidence. This includes a recognition that observation is not a neutral act in a vacuum. It is a practice performed within communities of scientists, institutions, funding structures, and cultural norms. The who counts as an observer question, and the role of instrumentation, measurement standards, and replication practices become essential in the craft of reliable knowledge. The empiricist emphasis on observation is thus complemented by attention to the social epistemology of science, how communities generate, test, and validate knowledge, and how power and resources shape what counts as evidence. Second, the ongoing development of interpretive frameworks that shape our understanding of experience. This includes the recognition that our sensory data must be embedded within theories and models, whether in physics, chemistry, biology, or social sciences. The modern picture often uses a pragmatic lens. A theory is empirically adequate if it yields reliable predictions and coherent explanations for a wide range of phenomena. The interpretive turn does not reject experience. It enriches the story by showing how data are meaningful only when placed within a coherent theoretical structure. This line of thought resonates with Kant's insistence on the necessary interplay between sensibility and understanding, a bridge that has proven generative for decades of scientific philosophy. Cross-references and a sense of historical conversation in thinking about origins and core principles, we are reminded that the story is not linear but dialogic. The tension between empiricism and rationalism is a persistent motif, as is the interplay between observation, theory, and method. The prefiguration of induction in Bacon, the careful cataloging of Aristotle, the optical experiments of Ibn al-Haytham, the theories of Locke on ideas and experience, the skeptical caution of Hume, and the critical reformulation of Kant all belong to a single conversation about how humans come to know, how confidence in knowledge is warranted, and how best to pursue truth in a world that can surprise us. The structural path of this narrative, then, is not simply a timeline but a map of ideas, starting with the sense that observation matters, proceeding to the insistence that careful testing and controlled inquiry are necessary, moving to the claim that ideas must be shaped and constrained by experience, and crucially, by the mind's own interpretive structures, and finally arriving at a modern landscape in which empirical methods underpin the sciences and rational critique keeps pushing us toward greater clarity and more robust evidence. Conclusion: toward a living practice of empiricism in the modern age. As we close this historical chapter, what remains central is a disciplined confidence in experience as the starting point of knowledge. tempered by the recognition that experience alone does not speak for itself without the mind's organizing work and the community's norms for testing, verification, and revision. The core claim, knowledge grounded in sensory experience, the central role of observation in forming ideas, and the move from particular experiences to generalized claims, remains a sturdy compass for scientific inquiry and ordinary life alike. If you picture the path as a triangle, with observation at the base, ideas rising from those observations in the middle, and generalizations at the apex, we can see how the shape is sustained by the methodologies we inherit and refine. The apex is not a final, static endpoint. It is a horizon we approach with new instruments, new data, and new questions. The ancient world taught us to observe, to describe. The medieval and Islamic scholars taught us to test and to measure. The early moderns taught us to generalize, to build theories that can be tested across contexts. Today's scientists, clinicians, engineers, and data analysts walk along that same line, translating the long arc of empiricism into interventions that affect lives and decisions. The questions remain: how might new technologies, machine learning, big data, advanced sensors, reshuffle the relationship between observation, interpretation, and generalization? How do we keep the integrity of evidence when data streams grow large, complex, and noisy? How do we balance the humility of recognizing our limits with the courage to push toward more reliable knowledge? These are not merely philosophical questions. They are practical concerns about how a society learns and improves. They call us to cultivate the empirical habit with discipline and care, to respect the data, to test our ideas, to remain open to revision, and to recognize that every inference stands on a scaffold of observation, measurement, and reason. And as we follow that scaffold, we keep alive a long, patient conversation about how we know what we know and why it matters that we know it at all. Before we move to the next section, a brief invitation to the viewers. In the upcoming segment, we will deepen our understanding of the empirical method by examining how laboratory practices, field observations, and record-keeping in early science shape the development of modern experimental practice. We will examine more primary texts, compare how different thinkers framed the act of observation, and explore how diagrams and timelines can illuminate the path from data to theory. If you're watching with notes, consider sketching a timeline on the page, listing the key figures with a few keywords about their methodological emphasis. Imagine a simple diagram that connects observation to generalization, with a few arrows representing the iterative steps of hypothesis, testing, and revision. And perhaps most importantly, listen for the way the voices of Aristotle, Ibn al-Haytham, Bacon, Locke, Berkeley, and Hume, so different in tone and aim, still share a common conviction. That to know anything at all is to begin with looking, and to test what we see with careful hands and disciplined reason. If you'd like, we can include specific prompts for your own diagrams and excerpts from primary sources for the next segment. We can provide suggested passages to read, short excerpts from Aristotle's biological writings, from Bacon's Advancement of Learning, from Locke's essay, from Berkeley's Principles of Human Knowledge, and from Hume's Inquiries. That will allow us to compare the language of the authors and to see how their sentences carry forward the empirical project in distinct but complementary ways. The aim is not to settle the matter once and for all, but to keep the conversation alive, to attend to the evidence, to respect the limits of observation, and to remain curious about how the mind, the world, and our shared practices of inquiry together produce knowledge that we can trust, refine, and apply. With that, we turn to the next section, where we will extend the discussion into the methodology of empirical inquiry, the historical context more deeply, and the practicalities of early scientific practices. We will guide you through the design of experiments, the construction of timelines, and the extraction of primary source excerpts in ways that invite you to engage, reflect, and question. We will, in short, keep the flame of empiricism alive, calm, steady, and attentive to the world's evidence, always asking, what have we learned, how do we know it, and what remains to be tested? Close your eyes for a moment and listen as we trace a line from ancient observation to modern skepticism, not as a dry chronology, but as a living dialogue about what we can know, where that knowledge comes from, and how it can be justified. The story begins with Aristotle, moves through medieval retoolings of the same questions, and then accelerates into the early moderns who recast the whole enterprise as a commitment to experience. From there, the path sharpens into a full-blown epistemology that centers experience as the primary source of knowledge, and in which the status of ideas, the role of sensation, and the problem of justification become the battlegrounds of philosophy. The figures at the center of this section, Locke, Berkeley, and Hume, are not merely historical milestones. They are living interlocutors in a centuries-long conversation about how we come to know anything at all. We begin with Aristotle, a thinker who still shapes how we imagine the authority of experience. Aristotle did not treat knowledge as a static possession poured into a mind from above. He treated it as a disciplined movement from sense to perception to generalization. In biology and natural history especially, Aristotle's method was to observe carefully, to note similarities and differences, to organize them into categories, and then to infer general principles. If you watch a naturalist catalog the behaviors of plants and animals, you hear in the background the Greek conviction that experience is not a mere heap of particulars, but a matrix from which universal claims can be drawn. And yet Aristotle is not a naive empiricist simply collecting sensory data. He believes in causes, formal, final, efficient, material, and in the teleology of nature. He does not separate what we see from how we reason about why it is the way it is. The empirical method for Aristotle has a normative dimension. Our observations aim for understanding, and understanding requires an interpretive frame, an account of why things are as they appear to be. This orientation toward systematic observation and generalization feeds the long arc of empiricism that later traditions will reshape and intensify. Aristotle's insistence that our knowledge begins with sense and is refined by reasoning becomes, in the hands of later thinkers, a program. We will not accept ideas as given from some heavenly source or as innate fantasies of the mind. We will instead trust the world we experience and the tools we develop to organize that experience. Yet Aristotle's own theory also leaves room for questions that later empiricists would carry forward and complicate. What counts as evidence? How do we justify the general claims we draw from a finite set of observations? And what is the status of the mind's ideas once they have been produced by experience? These questions will echo through the medieval period, where thinkers try to reconcile experience with faith and reason, and into the modern era, where they will be reframed as decisive tests for an entire epistemology. In the medieval period, empiricism begins to take on a distinctive flavor as it meets Christian theology, Aristotelian philosophy, and the emerging practice of natural inquiry. The scholars of the Middle Ages do not abandon observation, but they sometimes fuse it with doctrine, interpreting nature as a theater of divine purposes. Yet there is also a strong current that pushes toward experience as a legitimate ground for knowledge. Think of the Islamic and later scholastic traditions that emphasize observation and experiment as checks on speculative theory, even as they insist that faith and revelation have a legitimate, sometimes authoritative, place next to or above experience. We can hear this tension in the way medieval natural philosophy treats sensation and reasoning. Sensation provides raw data, reason and demonstration organize that data. And revelation provides the framework within which the data are interpreted. In this sense, the medieval project is not a retreat from empiricism, but a reconfiguration of it, a preparation for the emergence of a modern empirical program that can be rigorous about sources of justification while staying faithful to broader commitments. When the early moderns arrive, the stage begins to tilt decisively toward the epistemology we associate with modern empiricism. The shift is not merely historical, it is methodological. The early modern period emphasizes critique of inherited authority and a renewed confidence that human beings can ground knowledge in the structure of experience itself, provided we articulate clearly what counts as evidence and how it justifies belief. And at the heart of this shift stand three towering figures, John Locke, George Berkeley, and David Hume. Each takes the core intuition of Aristotle and the medievals, a claim that experience is indispensable for knowledge, and recasts it in a sharper, more radical form. They disagree about details, they challenge each other, and they anticipate later inquiries in ways that continue to illuminate how we think about knowledge today. Let us turn to John Locke, a physician and political thinker who writes at the cusp of the 17th century, in an age anxious about where knowledge comes from in a world that has suddenly become overcrowded with new scientific claims and new ways of testing them. Locke's central claim about knowledge is deceptively simple and philosophically sturdy. The mind at birth is not a storehouse of innate ideas, but a blank slate. He writes in effect that we begin with a mind devoid of content, and that all the ideas we later hold come from experience. The famous opening image, though often quoted as if it were a single line about a blank page, encapsulates this program. The mind at birth and the way it is filled, not by inborn content, but by the impressions it receives from sensation and from reflection on those sensations. And what counts as impression, what counts as idea, and how those ideas are organized into knowledge becomes Locke's decisive work. Locke's claim about the sources of knowledge is explicit and clear. Nothing enters the mind that did not come, at least originally, through sensation or reflection. If you ask where the mind gets its ideas, Locke says, it comes from experience. Sensation provides the mind with simple ideas of color, taste, sound, temperature, and so on. Reflection, on the other hand, offers the mind ideas about its own operations, how it compares, contemplates, and puts together those simple ideas. This dual channel becomes the backbone of Locke's late 17th century empiricism. He is careful to separate the two sources because he wants to preserve a role for reason without granting it autonomy to create content independent of experience. And he makes a striking and often quoted claim about the limits of knowledge. No man's knowledge here can go beyond his experience. This line is not a cynical capitulation to ignorance. It's an assertion about the boundary conditions of human understanding. To know something, one must be able to connect it to what the senses have provided or to the mind's own operations upon those senses. Locke's theory of ideas, especially his distinction between simple ideas derived from sensation and complex ideas formed by reflection, is not merely a taxonomy. It is a program for how justification works. If all knowledge begins in sensation or reflection, then justification for claims must ultimately trace back to experience or to the operations of the mind upon experience. Simple ideas are the atoms of knowledge. Complex ideas are built by the mind through processes like combination, order, and abstraction. The way Locke analyzes the mind's activity makes justification a matter of traceability back to the original impressions. This is why he insists that when we say we know something, we are always pointing to the chain that begins with a sensation and ends in a judgment formed by the mind's manipulation of ideas. Two concrete examples can illuminate this theory in action. The first is the distinction between simple ideas derived from sensation and complex ideas formed by reflection. Picture the sense of color, red or blue or green. These are simple ideas, the raw materials that come from perception. They are not derived from other ideas but from direct sensory input. Now imagine a concept like apple. The idea of an apple is not a simple idea but a complex one formed by combining several simple ideas. The color red or green, the shape of a sphere, the taste we associate with sweetness, the texture of the skin, the scent of the fruit. Locke would say, the mind is capable of assembling these simple ideas into a more complex unit, an apple. But that complex unit is still rooted in the simple sensations and the mind's reflective operations on them. The second example concerns abstract ideas, the concept of causation, or the idea of a substance, or the idea of a universal beauty. Locke believes that many of these are complex ideas built by reflection on various experiences. We notice regularities, the way one event follows another, the way objects persist through time, the way a pattern repeats under various conditions, and from those reflections we form ideas like cause and effect or substance or the essence of a thing. Yet this is where his position becomes tellingly subtle. For Locke, such complex ideas are still dependent on the mind's capacity to connect ideas and to generalize from particular experiences. They do not appear with independent authority outside of experience. A striking and historically lively anecdote helps to illuminate Locke's epistemological stance. In the late 17th century, Locke engages with a problem that is famous as Molyneux's question. If a man born blind has learned to distinguish a cube from a sphere by touch, would he be able to do so by sight once he regains sight? This is not merely a clever riddle about vision. It is a test case for how much of what we know is derived from sense alone and how the mind translates impressions across modalities. Locke's engagement with this problem in the essay concerning human understanding invites us to see him performing an epistemological experiment of sorts. It is a mental experiment about the mind's capacity to transfer knowledge from one sense to another and to reveal what is and isn't given by sensation alone. The problem is also historically telling because it exposes a tension between the empiricist commitment to sensory foundations and the rationalist intuition that some forms of knowledge may be more, or more immediately, accessible to the mind, even if we cannot yet demonstrate them across sensory modalities. For Locke, the mind's capacity to reason about ideas is not a magical leap beyond experience. It is a sophisticated operation on the inventory of sensations and reflections, a method of turning raw data into organized thought. This brings us to Berkeley, who stands as the next bold step in the empiricist lineage, but who refuses to leave the ground of sensation as the ultimate source of knowledge. Berkeley's program is often summarized by his insistence that to be is to be perceived. In Latin, esse percipi, this maxim is not a dismissal of reality as such. It is a radical insistence that the primary carriers of reality are the perceptions themselves, and that what we ordinarily call objects, tables, mountains, threads of color, are not independent substrate beneath our ideas but bundles of sensations present to minds. Berkeley is not merely challenging Locke's claim that ideas exist in the mind, he is contesting the very notion that abstract things exist independently of perception. He pushes the empiricist project to its absolute limit. If knowledge is grounded in experience, and if experience is always a function of perception, then how can we meaningfully claim that unperceived objects, what philosophers later termed the external world, have an existence independent of perception? But Berkeley's critique of abstraction is equally crucial. He argues that the mind cannot form abstract ideas in the way some philosophers have claimed. When you think of redness as a general quality, Berkeley asks you to consider whether you are really having a single abstract idea of redness that applies to all red things. He contends that the mind does not actually form such abstract ideas in the way textbooks sometimes picture them. Instead, what we have are particular sensations of color, particular shades, in particular contexts, compounded with particular acts of perception. The idea of a general red, an abstract quality distinct from any empirical instance, cannot be cleanly pulled from experience, because every instance of red is tied to a particular perceiver, context, and sensory apparatus. Berkeley's program is to insist on the primacy of perception, while simultaneously challenging the idea that perception yields a robust universe of abstract entities that stand independent of minds. From Berkeley's radical empiricism, we can derive two concrete examples that crystallize his claims. The first is his critique of abstraction. Think of the everyday habit of subtracting the particular from the particular to form a universal term, such as red. Berkeley asks you to reflect on whether you ever sharpen that term into an abstract property that exists apart from red things as they appear to you. He argues that the abstract idea of redness is a fiction that habitually misleads us into thinking there is a property that red things share beyond the sensations they produce. The second example concerns ordinary objects, the table you see in the room, the chair you might sit on, the tree outside the window. For Berkeley, these objects are not inert substrata that exist independently of our perception. Their existence for us is intimately tied to perception, yet this claim is not a denial of the world's regularities or of God's role in sustaining order. In Berkeley's view, God guarantees that the world continues to appear coherent to us, even when we are not actively perceiving it, but the persistence of entities depends on perception, first within minds and ultimately within the divine mind. Two historical anecdotes help illuminate Berkeley's stance in the 18th century. First, Berkeley's dialogues, especially those in three dialogues between Hylas and Philinus, are not mere argumentative exercises. They are crafted as living conversations, in which Hylas represents the common-sense habit of assuming objects exist independently of perception, and Philinus counters by insisting that what we call the table, or the chair, is a bundle of ideas that depends on perception. The dialogues dramatize the epistemic tension between ordinary, everyday belief and the more radical claim that the existence of ordinary objects is grounded in perception. The reader is invited, indeed, it is meant to be felt, to see the appeal of Berkeley's coherent vision of perception, even as it unsettles the ordinary assurance of a stubborn, material world. The other anecdote concerns Berkeley's response to skeptical challenges about external reality. As debates raged about whether things exist when not perceived, Berkeley offered a bold alternative. Even if things exist only as perceivable ideas, their orderliness and regularity are preserved by God, whose perceiving mind ensures continuity. The story is not merely a philosophical argument. It is a moment in the history of epistemology when the pressure of skepticism became so acute that a radical reinterpretation of existence seemed necessary, and Berkeley's response was to relocate reality within the mind, and ultimately within the divine mind. If Berkeley pushes empiricism to its radical edge, Hume takes the next crucial step and makes a decisive turn in our understanding of experience and justification. Hume's program is not to deny the role of experience. It is to scrutinize what experience can do for a theory of knowledge. He traces all knowledge to impressions, vivid, lively experiences, and the ideas that are fainter copies of those impressions. In the treatise and in the inquiry, Hume sets out a sharp demarcation between impressions and ideas, and insists that the contents of the mind are ultimately derived from sensory or emotional experience. Impressions are the sources of all our beliefs. Ideas are the weaker mental copies that we form by reflecting on these experiences. This distinction matters because it grounds justification in the experiential data that streams through the senses and into memory and imagination. If your supposed knowledge rests on impressions, then the strength of that knowledge depends on the reliability and regularity of those impressions across time and space. but Hume also invites radical doubt into the enterprise of knowledge. Two of Hume's most famous moves bear repeating here. First, he reframes experience as the ground of all knowledge about matters of fact and causal relations. The causal connections we ordinarily rely on, a cause is B, the sun will rise tomorrow, medicines will heal, cannot be justified by reasoning from the observed appearances alone. Hume shows that our inferences about the future from the past rest not on demonstrative certainty, but on habit or custom. We expect the sun to rise because we have learned to expect it, and our minds form strong expectations based on repeated experiences of constant conjunction. There is nothing in experience that guarantees that the future will resemble the past. Indeed, all the logic of inference presupposes some stability of nature that experience alone cannot justify. The consequence for Hume is not a rejection of science, but a demand that we recognize the limits of justification grounded in experience. The second move is to distinguish impressions from ideas in a way that makes the content of our thoughts subject to careful scrutiny. Our ideas are not forged from necessity, but are derived from the impressions we have had. When we abstract, generalize, or infer, we are dealing with the mind's operations rather than with solid empirical givens. And when we chase causation to its ground, we discover that what we treat as necessary connection is, for Hume, a product of habit, not a truth of reason. Two short quotations from Hume illuminate his core claims. The first is the simple, explanatory line that all the perceptions of the human mind resolve themselves into two kinds of perceptions, which I shall call impressions and ideas. The second, even more consequential for the theory of knowledge, concerns induction. When we look into the causes of any effect in nature, we never can deduce the connection between the cause and the effect by reason alone. We become confident in it by custom. These lines place experience at the center of justification, but also reveal the vulnerability of inductive knowledge. It rests on habit, not on a logically necessary guarantee. Hume's insistence that impressions are the primary data of experience makes his empiricism both powerful and precarious. He is unable to provide a firm rational foundation for scientific laws in the sense that the rationalists hope to offer, and yet he preserves the project of grounding knowledge in observable life, what we actually sense, feel, and reflect upon. This is where the two major lines of critique, the rationalist and the skeptic, enter the conversation as counterarguments to empirical theories in the lineage we are tracing. The rationalist objection, most famously associated with Descartes and his followers, argues that reason and innate structures shape knowledge in foundational ways. The rationalists insist that the mind brings to experience a priori forms or structures that organize sensation into coherent content. Space and time, mathematical truths, and certain ideas are seen as independent of sensory data and accessible through reason alone. Descartes' famous dictum, "I think, therefore I am," signals a claim about the certainty of self-awareness that does not depend on external evidence. Leibniz and others' systematic arguments for innate ideas and the pre-existence of rational structures also stand in explicit opposition to Locke's blank slate. They argue that even our most basic concepts require a prior architecture in the mind or the soul, a framework that experience alone does not supply. The empirical program can accommodate such objections by acknowledging that knowledge may be derived from experience, but that experience is itself structured by innate or a priori resources, things like logic, mathematics, or the very categories through which the mind organizes data. The tension between empiricism and rationalism thus becomes a dialogue. How much of our knowledge is the result of pure reason, and how much is a refinement of sensory input through inherited or built-in cognitive structures? The skeptical objection raises a different set of concerns. Even if experience is the source of our knowledge, can we reliably trust sense experience as a universal basis for truth? The worry is that our senses are notoriously fallible, and the contents of our experience can be deceiving under conditions of illusion, error, or manipulation. The dream argument, the illusion of an external world, the possibility of a skeptical demon, these are not merely quaint thought experiments. They are persistent reminders that experience may mislead us, and that justification demands criteria beyond mere belief because of what appearances can be. Hume's own view is a careful articulation of this philosophical hazard. He does not simply deny the objectivity of the empirical discoveries of sciences, he reframes them. He asks us to see clearly what we are relying on when we infer causal connections, when we assume that the sun will rise tomorrow, or when we generalize from a single instance to a general law. The skeptical challenge remains alive, but the empiricist movement, Locke, Berkeley, and Hume, responds by sharpening the tools of inquiry, clarifying the sources of ideas, and insisting that justification is anchored in experience in a well-ordered way. We can see the tension in the way these thinkers handle the problem of induction, a problem that later philosophers would take up with renewed urgency. For Locke, the justification for general claims rests on an accumulation of experience and the mind's capacity to generalize from a series of particular sensations. The problem, however, is the leap from the many observed instances to the universal claim. For Berkeley, the problem of induction is reframed in a more radical way. Given the reliance on perception, how do we know that the perceptual order we experience is the same order others experience? If perception is the ground of reality, then agreement among perceivers and the stability of perception across time must be explained. For Hume, induction becomes a fundamental puzzle. We have no rational basis to claim that the future will resemble the past, and yet we rely on such conclusions every day and in science. The answer, if there is one in Hume's language, lies in the psychology of habit and expectation. We are disposed to expect regularities because of how we have learned to associate impressions across repeated experiences. The empirical program thus yields a robust, perhaps provisional, epistemology. Knowledge arises from experience and is justified through the careful examination of how ideas are produced, how they relate to impressions, and how our inferences about the world mature through repeated contact with what we sense. Let us now turn to the broader landscape, the real-world applications of empiricism, and the modern interpretations that render these ancient and early modern debates relevant to today's science and humanities. The empirical program, as it matures, becomes inseparable from the scientific method. The claim that evidence must be gathered through observation, experiment, measurement, and testing becomes a practical doctrine in medicine, physics, biology, psychology, and social sciences. In education, empiricism informs how we structure learning environments so that students' knowledge grows from concrete experiences that can be observed, tested, replicated, and refined. In public policy and law, testimony and evidence are valued precisely because empirical claims can, at least in principle, be checked against experience. The world crowds in. Data collection, controlled experiments, peer review, replication studies, and statistical inference become the scaffolding that supports an epistemology grounded in experience. But the modern interpretations of empiricism also reveal tensions and revisions. Kant's critical project, for example, is often read as a response to Hume's skepticism. Kant suggests that while all knowledge begins with experience, it does not follow that all knowledge is derived from experience in a straightforward sense. He argues that the mind brings to experience a priori categories through which we organize sensory data: space, time, causality, unity, and substance. In Kant's hands, empiricism gains a new ally. Reason is not replaced by experience. Rather, experience is shaped by reason's organizing framework. This move, reconciling the empirical data of science with the necessity of certain logical and mathematical forms, marks a turning point in the history of epistemology. It also foreshadows later naturalized and pragmatic accounts of knowledge, in which the focus shifts to how human beings use experience to navigate and predict the world, to how science becomes a method of creating reliable and useful models of reality, rather than a route to absolute, contextless certainty. As we consider the arc from Aristotle through Locke and Berkeley to Hume, and toward Kant and beyond, the cross-references illuminate a network of ideas about the sources of justification, the status of ideas, and the role of experience in shaping belief. Aristotle's observation-based method has a lasting influence on the way science organizes inquiry, by starting from observations, classifying them, and building theory from the ground up. The medieval elaborations, with their insistence on harmony between faith and reason, remind us that empirical inquiry does not exist in a vacuum, but must be coherent with broader commitments about value, meaning, and purpose. The early moderns ground their empiricism in the clear claim that knowledge arises from experience, but they also show how experience might require a careful, disciplined theory of the mind's operations, how ideas are formed, combined, abstracted, and justified. And Hume's radicalization of experience as the sole wellspring of impressions and ideas, and his insistence that induction cannot be guaranteed by reason, pushes epistemology to its limits, forcing philosophers to rethink what counts as knowledge, what it means for beliefs to be justified, and how we should live with uncertainty. Two essential motifs run through this history and deserve particular emphasis because they prepare us for a robust, nuanced understanding of how empirical claims mature into a full-blown epistemology. First, the problem of induction and justification remains central. If we start from experience, how do we justify general laws and universal claims? Locke's solution lies in a careful reading of the mind's powers to generalize from a sufficient corpus of experience while remaining aware of the limits of experience. Berkeley challenges the very assumption that general abstractions correspond to independent realities, while Hume keeps us honest about the limits of what experience can certify, insisting that our strongest claims rest on habits of thought rather than on demonstrable necessity. The second motif is the tension between the claim that experience is the foundation of knowledge and the insistence that experience itself is structured by cognitive faculties, by forms of perception, by language, and by culture. The rationalist challenge, whether there are innate ideas or a priori structures that shape what counts as evidence, remains a persistent countercurrent against an unqualified empiricism. The skeptical challenge, whether sense experience can reliably ground universal truth, remains a practical and theoretical hazard that science meets by developing instruments, methods, and theoretical frameworks that test and refine our beliefs. In this light, the thinkers in this lineage are not simply sequential steps toward a fixed doctrine. They are dialogical voices that shape one another's claims, testing and revising what it means to know. Locke's insistence on the mind as a blank slate is sharpened by Berkeley's critique of abstract ideas, which in turn motivates Hume to scrutinize the very mechanisms by which experience becomes knowledge. The line from Aristotle to Hume is thus not a straight ascent but a living, sometimes uneasy, conversation in which experience is central, while the status of ideas, the reliability of sense data, and the possibility of grounding knowledge in a non-experiential foundation are constantly negotiated. As we close this section, pause to note two practical implications. First, empiricism, in its mature form, underwrites a disciplined approach to evidence. It demands that we trace beliefs back to their experiential roots, test the reliability of sensory data, and continually examine how our cognitive processes contribute to the formation of ideas. Second, the project leaves room for legitimate skepticism. It asks us to be wary of overconfident claims to certainty, to recognize the contingency of our inferences about the world, and to accept that some of the most profound questions about knowledge require ongoing inquiry, refinement, and humility before the complexities of experience. To borrow from Hume's own cunning spirit, the history we have traced is not a tale of certain knowledge sliding smoothly from sensation into science. It is a story of methods of observation, of careful argument, of testing and retesting and revising in light of new data and new reflections. It is a story about how empirical claims become mature epistemology through disciplined inquiry, through cross-referencing with rationalist challenges, and through confronting the stubborn questions that experience itself cannot fully resolve. In the end, the trajectory from Aristotle to Hume teaches us a distinctive humility. Knowledge begins in experience, but its justification requires a careful choreography of perception, thought, and critical scrutiny that acknowledges both the power and the limits of what we can know. If you listen closely, you can hear the echo of Aristotle in Locke, a reminder that the mind's journey from sensation to understanding is an ascent from concrete particulars to universal claims. You can hear Berkeley challenging us to explain the persistence and coherence of the world without appealing to a mysteriously detached substance, insisting instead that the order of experience be explained within mind and, ultimately, within God. And you can hear Hume sharpening the blade of empiricism, not to cut away the possibility of knowledge, but to cut away the pretensions of certainty that cannot withstand the scrutiny of the empirical life. Across these voices, we see a robust program. Empirical inquiry is not a collection of isolated opinions, but a disciplined historical project, one that seeks to ground our strongest claims in sensory experience, while continually interrogating the conditions under which experience justifies belief. This is the trajectory that shaped modern epistemology, and it is what this section aims to illuminate, how empirical claims mature into a comprehensive, nuanced account of knowledge that remains alive to the world's stubborn, sometimes disquieting reality. And understanding this trajectory is essential, because it grounds the subsequent chapters in which the conversation between empiricism and its critics continues, evolves, and ultimately invites new forms of inquiry about what it means to know anything at all. Empiricism begins not as a single thunderclap, but as a sustained invitation to take measurement, to test ideas against the rough and stubborn surface of the world, and to let that surface speak back with a disciplined testimony. If philosophy asks what we can know and how we come to know it, empiricism answers with a method. Gather careful evidence, subject ideas to controlled tests, let predictions be confronted by observation, and allow the best explanations to emerge from the best fit between theory and experience. It is a story about habits of mind and about communities of practice, as much as about experiments in laboratories. It begins in earnest with a shift away from revering authorities and toward revering the stubborn facts that reveal themselves when the mind is willing to look closely, to question, and to repeat. Let us begin with a figure often cited as the lodestar of empirical beginnings, Francis Bacon. He did not merely write about knowledge. He mobilized a program for thinking that insisted the mind must be freed from its temptations and distortions if it is to learn the orderly nature of things. The ecosystem of his thought is built around an image of the idols, the distortions that beset human cognition. The idols of the tribe, the cave, the market, and the theater, as he calls them, stand as warnings. Our shared human tendencies incline us toward quick conclusions, biased interpretations, and careless assimilation of authority. If you like, you can hear Bacon's call as a manifesto for disciplined inquiry. Cast off the idols, clear space for observation, and let the world reveal its regularities through careful use of instruments, systematic observation, and organized inference. He urged that the inquiry into nature must be conducted through direct experience, rigorous experimentation, and a method that transforms vague notions into testable propositions. In the famous phrase that often circulates in modern summaries of his program, the idea that knowledge is power, he gave science a weaponized clarity. To know is to have the capacity to explain, predict, and intervene. The exact words ipsa scientia potestas, knowledge itself is power, condense a broader conviction. Knowledge that can be tested, corrected, and extended is knowledge that can change the world. From Bacon's seeds, a wider landscape begins to unfold. The first crucial move is to make observation and experiment not the appendages of authority, but the core of epistemic legitimacy. The idols, after all, do not vanish simply by rhetoric. They recede when the mind adopts a regime of evidence, a habit of cross-checking, and a communitarian discipline that prizes replication and openness. Bacon's program did not specify all the details of experimental technique. That would come later through a longer and more varied ensemble of practitioners, but it did insist on a reorganized approach to inference. He emphasized the difference between mere opinion and what could be established, step by step, through a process of recording, comparing, and summing up experiences. In this sense, his Novum Organum is more than a book of method. It is a map of how to think with the world, how to accumulate and test observations, and how to push beyond immediate appearances to reveal the underlying order of things. The culture he championed, a culture aiming to restructure how inquiry proceeds, would become a central feature of early modern science. The next strand in this story runs through Galileo, a figure whose life dramatizes the empirical turn not merely as a method but as a political, even a moral act. Galileo did not simply collect observations. He built an entire practice around how to gather evidence in domains that had previously been dominated by authority and tradition. In astronomy, his telescopic observations challenged the Aristotelian cosmos and the Church's prerogatives. He did not rely on one or two sensational discoveries. He cultivated a disciplined habit of systematic observation, repeated under varying conditions, and he drew careful inferences from what he could see, measure, and record. In motion, he conducted experiments that tested the intuitive assumption that heavier bodies must fall faster than lighter ones, or that weight determines speed. He devised experiments with inclined planes to slow motion, to decelerate it, to measure it, to compare different materials and angles, and to discover a relation between distance, time, and velocity that could be measured, replicated, and debated. The result was not merely a technical achievement, though it was that, but a demonstration that nature's regularities can be interrogated, and that the outcomes of our inquiries can be predicted with a degree of confidence that surpasses common-sense expectations. Galileo's scientific temperament extended beyond motion into astronomy. His observations of the moon's craters and mountains, of the 4 moons orbiting Jupiter, and of the phases of Venus all converged toward a shared aim: to show that the celestial realm is not a static, perfect sphere system, but a dynamic, observable world that can be studied, mapped, and explained through empirical methods. He did not claim that authority was dead. Rather, he insisted that authority had to bow to the evidence. In his own words and in the spirit of his age, the universe must be accessible to those who learn its language. And that language, as he came to insist, is mathematical. The famous assertion, often distilled into the line that the book of nature is written in the language of mathematics, echoes a conviction that empirical inquiry and deductive reasoning can be harmonized. Observation constrains theory, and mathematical form provides the precise instrument to articulate those constraints. Galileo's experiments with motion, his telescopic discoveries, and his insistence on controlled inquiry thereby exemplify an empiricism that is at once empirical and mathematical, experimental and conceptual. As the empirical enterprise deepens, it acquires a more robust method that would eventually be called the hypothetico-deductive framework. The core idea is both simple and demanding. Begin with a hypothesis, an educated guess about how the world works, deduce predictions that would follow if the hypothesis is correct, then put those predictions to the test by observation and experiment. If the results match, confidence grows. If they fail, the hypothesis must be revised or rejected. Induction, drawing general conclusions from particular cases, plays a crucial role in forming hypotheses, but the robust core of the method lies in deduction and testing. Predictions derived from a theory are the devices by which a theory earns its credibility. The strength of this approach is not that it eliminates all uncertainty. No method can guarantee certainty in a contingent world, but that it provides a structured path to extend knowledge by encountering, confronting, and in the best cases, falsifying our assumptions. This is where Newton enters as a master craftsman of empirical inquiry. He did not simply see nature as a set of self-evident truths. He set out to show how careful measurement, precise experimentation, and mathematical reasoning can yield deep explanatory accounts of physical phenomena. In optics, his prism experiments demonstrated that white light is not a simple, uniform entity but a composite of colors. He shattered a long-standing assumption about light and color, arguing that the spectrum can be dispersed and recomposed, so that color is not a primitive property but a result of the interaction between light and matter. The elegance of Newton's demonstration lay in its clarity. A seemingly simple observation, the splitting of white light, led to a comprehensive theory about the nature of light, color, and the properties of prisms, all of which could be articulated in precise mathematical terms. From this point of departure, nature begins to be understood not as a mosaic of appearances, but as a system in which mathematics provides a universal scaffolding for explanation. The story of empiricism does not stop with light and telescopes. It expands into the rigorous mass and measure tradition of Antoine Lavoisier, whose meticulous experiments and precise quantifications laid the foundations for modern chemistry. Lavoisier did not merely catalog substances. He reimagined chemical knowledge as a discipline governed by careful measurement, reproducibility, and the conservation of mass. When he announced that nothing is lost, nothing is created, everything is transformed in chemical processes, he crystallized a principle that reframes how scientists think about reaction, transformation, and the law-like behavior of matter. He insisted that the laboratory be governed by standards, that instruments provide reliable data, and that explanations be derived from those data through transparent and repeatable experiments. The culture of measurement he championed, careful weighing, precise volumetry, controlled reactions, and rigorous accounting of all inputs and outputs, became one of the empire's strongest legs for the growth of chemistry, biology, and physics under an empiricist banner. In this respect, the empirical method is not merely a set of procedures. It becomes a way of structuring inquiry so that the best explanations are those that persist under careful, replicable scrutiny. As the empirical method matured, it did not become a machine that dispenses conclusions. It matured into a framework that blends induction, hypothesis testing, and the disciplined use of deduction to generate explanatory power. Induction remains a fruitful starting point, not a guaranteed route to universal truth, but a way to identify patterns, to articulate regularities, and to propose generalizations that can be tested. The hypothetico-deductive method then adds a rigorous engine. From a hypothesis, we derive predictions that can be falsified by experiment. If the results align with the predictions, the hypothesis gains credibility. If not, it is revised or discarded. The predictive dimension matters. Science is not satisfied with a narrative of accumulation alone. It seeks explanations that enable us to anticipate novel phenomena, to forecast the outcomes of untested conditions, and to apply those insights to technology, medicine, industry, and policy. Two vivid cases help illuminate how this empirical enterprise plays out in concrete terms. The first is Galileo's experiments with motion and astronomy that challenged authority. Galileo's approach, careful experimentation, systematic measurement, and the use of instruments that extend our sensory reach, made it possible to question long-standing beliefs about nature that had been deemed self-evident. In the study of motion, he mounted experiments on inclined planes to slow down motion, allowing precise measurement of time and distance. By comparing the descent of different bodies, he demonstrated relationships that would later be described mathematically as kinematic laws. The results did not merely correct a particular error, they reshaped the entire attitude toward natural inquiry. The acceptance of new observational results required the flexibility to revise theoretical commitments, a willingness to let the evidence lead even when it unsettled entrenched authorities. In astronomy, Galileo's telescope revealed a cosmos that did not fit the scholastic picture: moons orbiting Jupiter, phases of Venus, sunspots, phenomena that suggested the heavens were not the perfect, unchanging theater that the old cosmology had promised. The combination of methodological discipline and radical observational evidence compelled a rethinking of the role of human senses in the pursuit of truth. The moral of Galileo's experiments is not merely that data can undermine dogma. It is that data, if pursued with disciplined technique, can expand the possible, shifting what counts as evidence and what counts as explanation. The second vivid example is Newton's prism experiments and the mathematization of nature. Newton's work shows how empirical observation can dovetail with mathematical reasoning to generate a new kind of explanatory power. He did not stop at noting that white light could be split into colors. He posed a question: what is the nature of light itself? His prism experiments demonstrated that color is not an irreducible property, but a feature that emerges from the interaction of light and matter. He then showed that the different colors could be recombined to produce white light, thereby arguing for a unifying principle of composition and decomposition that could be expressed through mathematics. This is a quintessential moment in the history of science, the empirical discovery that a seemingly simple phenomenon, light's color content, could be captured by quantitative analysis and mathematical description. The consequences rippled outward into physics and optics, encouraging a mechanistic view of natural regularities and the search for universal laws that could be stated with precision and tested with experiment. Newton's achievement extends beyond his laws of motion and gravitation. It marks a turning point in how science sees the relationship between observation and explanation, between data and theory, and between the roles of experiment and calculation in producing reliable knowledge about the natural world. As the method matures, it also encounters substantial philosophical challenges that force a re-examination of its grounds and limits. One of the oldest and most persistent counterarguments arises from David Hume's problem of induction. Hume asks a deceptively simple question: how can we justify moving from a finite number of observed instances to universal generalizations about all instances? He acknowledges that our knowledge of matters of fact, causal relations among events, derives from experience, but he points out that our confidence in such generalizations cannot rest on rational demonstration. He writes that all inferences from experience are the effect of custom, not of reasoning. In his telling, the habit of expecting certain outcomes arises not from a logically necessary connection, but from the repeated pattern of our encounters with the world. The fear and the insight here is that prediction, even when it works well, rests on a form of inductive reasoning whose justification is not airtight. This is the core of the problem of induction. The extrapolation from the known to the unknown cannot be guaranteed by logic, and yet science survives on the credence that patterns will persist. Hume's problem does not destroy empirical science. It unsettles it, reminding us that our strongest claims about unobserved or future phenomena are, at bottom, probabilistic and not logically necessary. The implications are profound. Science must be honest about its limits, and its power rests on the practical success of its predictions rather than on a guarantee of universal truth. A second, equally important critique concerns the claim that observation is theory-laden. The position argues that what we observe, how we interpret what we observe, and even what counts as an object of observation are deeply shaped by prior theory, assumptions, and conceptual frameworks. In this view, instruments do not merely reveal, they participate in construction. The scientific observer brings to the scene expectations about what counts as a phenomenon, what matters, and what would count as a robust test of a hypothesis. The language of observation, the design of experiments, and the interpretation of results are all embedded within a web of theories, models, and instruments. The critique is not that empirical methods are worthless, but that they are not theory-neutral. Our claims about evidence are always mediated by frameworks that themselves require justification. This idea reaches a high level in the work of Thomas Kuhn, who argued that science advances through recurrent cycles of normal science, crisis, and paradigm shift. A paradigm is more than a collection of theories. It is a whole worldview that structures what counts as a problem, what counts as a solution, what counts as permissible interpretation, and what counts as an experiment that will count as a test. In Kuhn's terms, the progress of science is not a simple, linear accumulation of facts, but a complex, sometimes discontinuous process in which prevailing frameworks shape the very content of what scientists observe and how they reason about it. The counterarguments connect crucially to broader theories about science. Karl Popper's response to the problem of induction is to reframe the enterprise around falsifiability rather than verification. For Popper, science progresses not by verifying universal theses through experience, but by making bold conjectures and attempting to falsify them through empirical tests. In this light, scientific theories gain credibility because they survive attempts to refute them, not because they have been proven with final and unassailable certainty. The emphasis shifts from inductive justification to critical testing. From this has worked so far to this would be ruled out if we found certain results. The idea is not to abandon induction, but to subordinate it to a disciplined method in which conjectures face rigorous scrutiny. In Popper's terms, a theory is scientific if and only if there is a possible empirical test that could refute it. Kuhn's contribution, by contrast, helps us understand how science is structured and organized over time. He shows that scientific activity unfolds within the shared commitments of a community, guided by a paradigm that gives scientists a common language, a shared set of exemplars, and standard problems to solve. Anomalies accumulate until the existing paradigm can no longer accommodate them, at which point a crisis gives way to a new framework that redefines what counts as evidence and what constitutes an acceptable explanation. The shift from a Ptolemaic to a Copernican cosmology, or from Newtonian mechanics to Einstein's relativity, is not merely a correction of data. It is a deep reconfiguration of the conceptual architecture through which the world is understood. The interplay of evidence and theory, of experiment and paradigm, is what makes science a dynamic and historically contingent enterprise. Kuhn's portraits of revolution do not deny empirical success. They illuminate how that success is framed, how evidence is interpreted, and how science changes not only its conclusions but its very standards of proof. And what about the more skeptical project of naturalizing epistemology associated with Willard van Orman Quine? In his polemical essays, Quine challenges the project of a purely a priori or purely foundational epistemology. He suggests that epistemology must be studied within the empirical sciences themselves, that our beliefs about the world are underdetermined by evidence and must be revised in light of the entire network of theories, instruments, and observations that constitute science. A famous line in his collaborative work with Charles Julian is the injunction to view belief as a web, not as a set of isolated, individually justified propositions. In this sense, epistemology becomes a naturalized enterprise, accountable to the very practices that generate knowledge, prediction, explanation, and the continual test of our most cherished theories against experience. Quine's stance does not deny the value of empirical inquiry. It reframes it as an interwoven enterprise in which theoretical commitments, experimental data, and interpretive frameworks must all be examined together. We should not regard these critiques as fatal flaws, but as two faces of one enduring challenge: how to account for the deeply interconnected, context-driven, and sometimes historically contingent practice of science. Hume's problem of induction reminds us of the fragility of our confidence in universal laws, while the theory-ladenness critique emphasizes the active role of theoretical commitments in shaping what counts as evidence. Taken together, they invite us to cultivate a more nuanced view of scientific knowledge, a view that acknowledges its extraordinary reliable power while remaining mindful of its provisional, revisable, and context-dependent character. Empiricism in this light is not a naked empiricism that simply lays bare the world. It is a disciplined enterprise that negotiates errors, revises assumptions, and grows stronger through rigorous testing, transparent replication, and critical dialogue within communities of inquiry. Two anecdotes help to anchor these ideas within historical practice. The first is Bacon's development of an organized approach to inference in the Novum Organum. In that work, Bacon does not merely present a catalog of techniques. He offers a blueprint for reorganizing the mind's habits of inference. He argues for a careful procedure by which observations are collected, events are categorized, and general rules are extracted from patterns of experience. The novel feature is not simply the insistence on data, but the insistence on a disciplined method of inference, an ordering of signs, signs that must be tested, and signs that must be checked against a broader array of observations. The image of an accusatrix of nature, as he stages the process, is compelling. Nature is not a capricious source of impressions, but a repository of regularities waiting to be recognized by a mind trained to observe, compare, and generalize. The Novum Organum is thus a crucial historical hinge. It marks the transition from a rhetoric of authority to a methodical program that binds empirical practice to rational inference. The occult powers of the idols are to be replaced by a method that invites discipline, replication, and progressive correction. It is a political as well as intellectual project. To democratize inquiry, to push beyond the limits of inherited wisdom, and to create a culture in which evidence can be communicated, tested, and refined. The second anecdote concerns the culture of early modern scientific societies that fostered replication and communication. The 17th and 18th centuries saw the rise of organized networks of scholars who believed that knowledge could be advanced through sustained collaboration, critical debate, and the rapid dissemination of results. The Royal Society of London, founded in 1660, stands as a luminous emblem of this culture. Its weekly meetings where experiments were demonstrated and discussed, and its journal Philosophical Transactions, which began publication in 1665, created a platform for shared standards of evidence, reproducibility, and argument. Figures such as Robert Boyle, Christopher Wren, Robert Hooke, and later Henry Cavendish, and others engaged in a lively exchange of ideas, methods, and results across borders. The Publisher-Scientist Network, embodied by the correspondents of Oldenburg, the Swedish natural philosophers, and the continental patrons of science, created a dynamic environment in which replication and verification were not afterthoughts but central modes of verification. The culture of replication, observing again, measuring again, confirming or correcting earlier findings, became one of the most durable claims of empirical science. Against this historical backdrop of method and community, the broader conceptual framework of science continues to develop. The hypothetico-deductive method, induction forming hypotheses and deduction producing testable predictions, grew out of these practical, collaborative traditions. The capacity to generate reliable explanations rests on this triadic structure. An idea to test, a prediction to test, and a method for testing. When a theory forecasts a novel, unobserved phenomenon, when the prediction is borne out by observation or experiment, the theory gains robustness. When the test fails, the theory must be revised or replaced. In practice, this is a creative, iterative, messy process, not a linear triumph over error. The vivid cases of Galileo and Newton illustrate this dynamic. Galileo's observations forced the re-evaluation of models of celestial motion. Newton's experiments and mathematics provide a unifying framework that yields new predictions about mechanics, optics, and the behavior of matter. The Lavoisier revolution reframes chemistry through measurement and principle, again showing how empirical methods yield qualitative breakthroughs through quantitative discipline. It is essential to notice how these stories link to broader themes of philosophy of science. Popper's falsifiability acts as a guardrail for scientific theories, insisting that science is not the accumulation of confirmed beliefs, but the continual willingness to risk falsification in light of new evidence. The emphasis on bold conjectures and courageous refutation gives empirical inquiry a dynamic ethic. It is not content to linger in dogma but seeks to illuminate by testing. Kuhn's analysis then explains why science does not grow by mere accumulation. It grows by shifts in the conceptual frameworks scientists use to interpret data. Anomalies accumulate, crises emerge, and a new paradigm redefines both what counts as evidence and how it should be interpreted. And Quine's naturalized epistemology pushes in the direction of a science that studies its own knowledge using the same empirical and methodological commitments it applies to the world. Knowledge, under this view, is a scientifically tractable phenomenon whose justification is continuous and evolutionary rather than foundational and a priori. These cross-references are not mere footnotes. They illuminate the way empirical methods interface with physics, chemistry, and biology. In physics, the hypothetico-deductive approach yields testable theories about motion, energy, and fields. In chemistry, the insistence on mass balance and controlled experiments transforms observations into laws of composition, reaction, and transformation. In biology, empirical methods guide the discovery of enzymes, genetic mechanisms, and evolutionary processes through careful experimental design and the interplay of observation and hypothesis testing. The boundaries between disciplines blur in the best empirical work, where a concept from optics informs a theory of signals and information, or a chemical measurement illuminates a biological pathway. The unity of the empirical project lies in its shared commitment to evidence that can be tested, to theories that can be revised, and to explanations that gain leverage from their predictive success. In this sense, the modern scientific method emerges as a robust, though imperfect, answer to questions about how we know what we know. It rests on a confident, calm acceptance of the fact that we must be prepared to weigh evidence, to revise our views in light of new data, and to recognize the provisional character of even our deepest theories. It acknowledges the problems that have haunted philosophy since Hume's day and integrates them into a living practice. A practice that invites skepticism about any single claim while celebrating the cumulative progress that arises when diverse minds test ideas against the world and against one another. The method's strength lies not in a final, unassailable justification of every belief, but in a track record of successful predictions, reliable explanations, and technological innovations that improve lives. The method's limits, underdetermination, the possibility of theory-laden observation, and the persistent reminder that induction cannot guarantee universal laws, do not undermine science but calibrate it. They remind us that science is a human enterprise, robust because it is corrigible, open to criticism, and anchored in the social structure of inquiry that Bacon imagined and that the Royal Society helped to realize. For those who wish to explore these themes further, several lines of inquiry offer especially fruitful cross-references. Popper's insistence on falsifiability directs attention to the moment a hypothesis is put to the test. It invites us to assess not whether a theory is beautiful or elegant, but whether it survives attempts to falsify it. Kuhn's portrayal of scientific revolutions invites us to consider how the creation of new paradigms redefines what counts as evidence, how instruments are used, and how scientists interpret anomalies. Quine's naturalized epistemology challenges us to see knowledge as a product of the natural sciences' own methods, not as an independent, a priori justification of belief. Together, these perspectives illuminate how empirical science is both a remarkable achievement and a project that must continually justify itself in the face of criticism and change. As we reflect on the arc from Bacon's organized inference to Galileo's observational program, through Newton's quantitative experiment to Lavoisier's measuring discipline, and onward into the modern hypothetico-deductive enterprise, we see a coherent thread. Empirical methods evolve because they are tested against the world, refined through collaboration, and durable enough to produce not just knowledge but technologies that reshape culture. The heirs of this tradition may differ in emphasis, some stressing falsifiability, others the social dynamics of science, still others the cognitive underpinnings of observation. But they share an abiding confidence in a method that treats evidence as something to be treated with care, tested against the world, and integrated into explanations that can be communicated, debated, and improved. If the story feels at once technical and humanistic, that is not by accident. Empiricism is not a mere tally of experiments. It is a way of asking questions about what counts as evidence, how we know, and why certain explanations stand up to criticism while others crumble. It invites us to see science as a living tradition, one that began in earnest because thinkers like Bacon, Galileo, Newton, and Lavoisier reframed inquiry in terms of observable, measurable, and testable elements of reality. It invites us to see science as a communal achievement, a culture of replication, debate, and shared standards that makes knowledge portable across times and places. And it invites us to see science as a robust enterprise that continually tests itself, learns from its mistakes, and remains open to revision even as it yields extraordinary explanatory power. The questions it raises about induction, about the role of theory and observation, about the boundaries of scientific explanation, are not just technical debates. They are questions about how we come to know anything with confidence and how we live with the provisional, dynamic, and deeply human craft of science. Let us settle into a quiet space and let the thread of empiricism unfold around us, not as a sermon, but as a conversation about how we come to know anything at all. Empiricism begins with a simple claim. Our beliefs about the world should ultimately rest on what we can sense, observe, or experience. But the road from that seed to a stable, shared body of knowledge is long and winding. It passes through bold critiques, sharp refusals to surrender to sensation alone, and careful reconciliations that try to keep the best of experience while admitting its limits. In this section, we move through challenges to empiricism, the responses that later thinkers offered, and the implications for science, language, and mind. We will tell stories of minds struggling with mystery, and we will hear the echoes of those struggles in the work of contemporary theories. If empiricism began with simple observations, the conversation soon grew into a debate about what experience can guarantee and how the mind must shape that experience to become knowledge. We begin with the origins, not to wallow in nostalgia, but to understand the soil from which the critique and the counterpoints have grown. The traditional lineage of empiricism begins most famously with John Locke, who insisted that the mind at birth is a blank slate, tabula rasa, and that all ideas originate in experience. The world furnishes us with ideas through sensation and reflection, and through a careful act of comparison and reflection, we build complex beliefs about objects, causation, numbers, and the self. Locke's vocabulary is lucid and practical. We gain knowledge by attending to the data of sensation, by grouping experiences, by forming ideas that correspond to patterns we detect in the flux of the sensible. The idea of the mind as a passive recipient of impressions might be criticized as too tidy, but the core claim is both simple and radical. There is no guaranteed access to innate ideas floating in the mind from birth. All ideas come from experience, and the mind, while active, remains shaped by what it has encountered. But the story would be incomplete without the presence of two other figures who raise the temperature of the debate, Berkeley and Hume. Berkeley challenges the more prosaic sense of material reality by insisting that the only things we can know with certainty are ideas and the relations among them. In Berkeley's famous slogan, esse percipi, to be is to be perceived, the material substance that supposedly lies behind appearances dissolves into a network of perceptions and the will or mind that orders them. Berkeley is not only defending a form of empiricism, he's arguing that the very idea of matter as an independent, mind-independent substrate is unnecessary if we attend to the way sensations and ideas appear to us. He is, in a deep and persuasive way, a radical empiricist. He refuses to let the claim of experience be overshadowed by speculative commitments about unseen substances. The story of the external world for Berkeley can be maintained by keeping perception central and by showing that the substance feared by empiricists is not a thing, but a consistency of ideas within our experience. Hume, writing after Locke and Berkeley, pushes empiricism toward a more skeptical edge. He invites us to examine the foundations of our causal reasoning, our beliefs in the uniformity of nature, and the notion that cause and effect have any necessity beyond habit and projection onto patterns we have repeatedly observed. Hume's critique is not merely epistemic treachery from a playful skeptic. It is a sharpening of what it means to know, a reminder that our sense of necessary connection often outstrips what we can justifiably claim on the basis of sense data alone. When Hume asks whether we can justify the belief in cause from experience, he doesn't reject experience. He asks what guarantee experience can offer us about the regularities we count on in science or about the self that experiences. The empiricist project thus confronts a profound question. If all ideas are derived from experience, how is it that mathematics, logic, and scientific laws appear to hold with necessity, not merely with description? This last question leads us to two generations of criticism, rationalist and innatist, that set up the tension we still wrestle with. The rationalists insist that some knowledge is grounded in reason alone, independent of sensory experience. Descartes stands at the heart of this tradition. He famously locates a bedrock of certainty in the very act of thinking, cogito ergo sum, I think, therefore I am. In the Meditations, he dissects beliefs and tries to peel away the unreliable from the certain, arguing that while the senses can deceive, reason can provide clear, indubitable ground for certain truths. The Cartesian program suggests that some knowledge about the self, about extension, about mathematics, begins with the rational structure of thought itself. While Descartes is not a pure empiricist, he sets a counterweight. If experience is fallible, perhaps some truths are accessible through the certainty of the rational mind, independently of what the senses tell us. 19th-century rationalist successors push the innatist claim more explicitly, arguing that certain ideas or structures are inborn, not derived from experience. Innatism is the claim that some knowledge exists in the mind prior to or independently of sensory contact with the world. One reason the issue matters is this: if there are innate ideas, then empiricism cannot be the whole story about how we come to know the world. The mind perhaps comes pre-equipped with forms or concepts that experience later fills in or corrects. The debate becomes not simply about whether experience can generate all ideas, but about whether certain fundamental structures, space, time, causality, mathematical necessity, are already in place in the human mind. Into this landscape steps Kant, who performs what he himself calls a Copernican revolution in philosophy. Kant's central claim is that knowledge begins with experience, but not in the sense that experience alone supplies all conditions of knowledge. He argues that the mind contributes a priori structures that shape how objects appear to us. Space and time, for example, are not properties of things in themselves waiting to be observed. They are the very forms through which we organize sensory input, the categories of the understanding, the ways we think about causality, unity, plurality, necessity, are not derived from experience in the sense of carting in raw data. They are productive of experience. They make experience possible as something that can be known. The famous turn of phrase that objects conform to our way of knowing rather than that knowledge must be a passive reflection of an independently given world signals a deep synthesis. Kant does not throw out empiricism, he corrects it, insisting that the mind's a priori scaffolding is indispensable to turning sensation into knowledge. In this sense, Kant offers a critical synthesis. He agrees that knowledge begins with the experience of the sensible world, but adds that the mind brings structures that transform that experience into knowledge of the world as it appears to us. He introduces the notion of synthetic a priori knowledge, propositions that are informative about the world and yet knowable independently of particular experiences. Mathematics, for him, is a paradigmatic example. The statements of geometry or arithmetic seem to be necessary and universal, yet they are not merely empirical claims about how many apples we happen to see on a table. They are framed by the mind's own laws of space and number. The famous line, "Thoughts without content are empty, intuitions without concepts are blind," captures the interdependence Kant sees between the material of experience and the form through which the mind organizes it. For Kant, the mind is not a blank screen. It is a lens with certain built-in structures that color and order what we can possibly know. Now, what are the concrete challenges to pure empiricism that keep the conversation alive? There are at least two robust ones that repeatedly press against the claim that experience, in isolation, provides us with the content and certainty of knowledge. First, consider mathematics and logic, which exhibit a form of necessity that seems hard to reconcile with a theory of knowledge grounded merely in sensory experience. If empirical data were all we could count on, why should Euclidean geometry or the basic laws of arithmetic retain their necessity regardless of the particular experiences we have? Why would the truths of mathematics seem to hold even when our sensory experiences contradict them? The empiricist might reply by saying that mathematical knowledge is derived from patterns we perceive and reflect upon. Or perhaps that mathematical reasoning is a discipline that trains the mind to see regularities. Yet many philosophers have pointed to a deeper kind of necessity that appears independent of particular experiences. Kant himself argued that mathematical judgments are synthetic a priori. They extend our knowledge about the world in a way that is not exhausted by any possible experience, yet they presuppose the forms of intuition and categories of the understanding that structure all experience. The challenge, then, is to explain how mathematics can have certainty and necessity if all our knowledge rests on sense data that could, in principle, be otherwise or be deprived of certain correlations. The second challenge concerns the transparency of experience itself. Perceptual illusions and cognitive biases reveal that what we take to be direct contact with reality is filtered and sometimes distorted by the workings of our sensory apparatus and our cognitive processes. The Mueller-Lyer illusion, where two lines of equal length appear different because of the arrow-like tails at their ends, suggests that our visual system interprets depth and perspective in ways that do not track actual lengths. The color appearance differences across contexts show that color experience is not simply a straightforward readout of the world's surface properties. It is affected by lighting conditions, surrounding hues, and contextual cues. These examples remind us that experience is not a perfectly transparent camera. Rather, it is a construction by the sensing organs and the interpretive machinery of the mind. Cognitive biases like confirmation bias, the availability heuristic, or the anchoring effect show that even our best reasoning can be systematically distorted by prior beliefs, salience, and framing. If experience is to ground knowledge reliably, what guarantees do we have in the face of these distortions? The empiricist faces a genuine problem: how to reconcile the trustworthiness of experience with the known frailties and biases of perception and cognition. From these challenges arise two powerful counterarguments to pure empiricism, arguments that invite us to rethink where justification and certainty come from. The first counterargument is Kant's transcendental critique. Rather than asking whether experiences match an external world exactly as it is, Kant asks what must be true of any possible experience in order for us to have experience at all. What are the preconditions without which empirical knowledge would be impossible? Kant's answer is that the mind supplies a priori structures, space, time, and the categories of understanding that organize phenomena into objects, causal relations, and coherent wholes. These structures do not merely color experience, they make experience possible by providing the very framework within which anything can be experienced. In other words, the mind contributes essential organizing principles that are not derived from experience but are prerequisites for experience to be possible. This is a robust challenge to the empiricist program because it locates necessary elements of knowledge not in the content of sensory input, but in the form of the mind's activity. The empirical data for Kant do not simply arrive as raw content, they are received through an already structured channel. The mind, to borrow a phrase of his, imposes a unity and order on the manifold of sensation. The second counterargument comes from a later thinker who refuses to accept the sharp boundary that empiricists wanted to draw between analytic and synthetic truths. Willard Van Orman Quine argues in a famous essay called Two Dogmas of Empiricism that there is no clean analytic-synthetic divide. If the analytic sentences were true merely by virtue of meanings and linguistic conventions, then they should be immune to revision in light of experience. But Quine challenges us to see that even logical and mathematical claims can be revised in light of the total body of empirical and theoretical commitments we hold. He uses a powerful metaphor. Our beliefs form a web, and experience is the surface tension on that web. To modify a belief in one corner of the web can require adjusting many other beliefs, not because we are irrational, but because our science is a holistic enterprise. If our evidence supports a new theory, we are not simply swapping out some isolated sentence. We are reweaving a portion of the web that supports our entire system. This holism about evidence, in Quine's hands, becomes a formidable challenge to the idea that we can isolate empirical content from analytic structure. If the language of necessity in mathematics, or even the logic by which we evaluate evidence, is not insulated from revision by empirical data, then empiricism must reckon with a much more radical interplay between experience and theory than its advocates sometimes allowed. These two counterarguments have a kind of reciprocal relationship with the earlier claims of Kant and the innatists. Kant's position does not deny the possibility that science can be empirical in content. Rather, it says the conditions of the possibility of experience require a mind that is not purely passive. The Quinian critique, by challenging the analytic-synthetic distinction, does not simply attack empiricism. It destabilizes the very scaffolding that many philosophers assumed the empirical project could rely upon. It invites us to look at science not as a straightforward process of reading off sensory data, but as a dynamic construction that integrates theory, evidence, and the language we use to describe both. If empiricism is to survive in a meaningful form, it must accommodate these kinds of insights, that there are a priori structures in our cognition that condition experience, and that the boundary between empirical content and logical or mathematical framework is more porous than once thought. To appreciate how these debates have unfolded over time, it helps to tell two historical anecdotes that illuminate their direction and stakes. First, consider Berkeley as a radical empiricist critique of materialism. Berkeley's critique did not simply aim to defend common sense about the given. It aimed to expose a hidden stubbornness in the materialist view, which pretends that matter has an existence independent of perception. In his dialogues, he stages a conversation between Hylas, the proponent of matter, and Philinus, who represents the empiricist critique. The conversation is not mere pedantry. It is a live argument about what we can know and what it would mean to doubt the reality of ordinary objects. If the tree falls and no one is around to hear it, is it still there? Berkeley's answer, in effect, is. The tree's existence is bound up with its being perceived or with God's perception. If either is absent, the language of existence becomes meaningless or at least ambiguous. The radical claim is not that perception creates reality out of nothing. It is that the language of substance beyond perception is a metaphysical surplus that cannot be supported by experience as such. In this sense, Berkeley remains within the empirical tradition. He grounds his arguments in observation, consistent with his anti-materialist reading of everyday experience, while pushing the boundaries of what must be assumed about the world that experience reveals to us. The second anecdote centers on Kant, whose project was to reconcile rationalism with empiricism without collapsing into a sterile skepticism or a naive realism. Kant's life spanned a moment when the rationalist and empiricist lines had produced impressive results, but also deep questions. How can mathematics be both synthetic and necessary? How can our knowledge of the world be possible if experience gives us only appearances? Kant undertook a bold move. He proposed that knowledge is not a mirror of the world, but a hand that shapes the world for us through its a priori structures. He called this the Copernican turn in philosophy because, like Copernicus in astronomy shifting the center of gravity from Earth to the Sun, Kant places the center of epistemology in the mind. He did not deny the trustworthiness of empirical observation. Rather, he claimed that the mind's categories, causality, unity, plurality, and its forms of sensibility, space and time, are necessary conditions for any experience to occur. Without them, there would be no coherent object, no stable event, no law-like regularity to discover. Kant's synthesis, then, is not a retreat from experience, but a disciplined articulation of how experience becomes knowledge through the mind's own architecture. As we move from these historical cases to contemporary discussions, two modern variants help illuminate the ongoing debate and point toward a broader horizon: constructive empiricism and naturalized epistemology. Constructive empiricism, advanced by Bos van Frossen, asks us to treat science as a tool for constructing empirically adequate theories rather than as a project aimed at discovering true descriptions of unobservable realities. The claim is modest in a certain sense. Science aims to tell us what is observable and how to predict observable phenomena. It does not pretend that unobservables, such as the precise nature of a quantum field or the ultimate mechanism behind a consciousness, are known or knowable in the same sense. This is a strategic concession to empiricism's challenges. It keeps faith with the empirical method while reframing what it means to know. The appeal of constructive empiricism is practical and pluralistic. It supports science as a working enterprise that remains robust even if the deeper nature of reality remains mysterious or inaccessible. Yet this stance must face questions about the status of unobservable entities in practice and how far one can go in confirming a theory that only targets the observable. Naturalized epistemology, associated especially with Quine, suggests that epistemology should be treated as part of empirical psychology. Rather than asking for a priori guarantees about knowledge, naturalized epistemology asks what kinds of cognitive processes and neural mechanisms underlie our beliefs, and how those processes are constrained by and interact with the environment. If our theoretical intuitions about evidence, justification, and belief formation are to be revised, they must be revised in light of empirical findings about the brain, learning, perception, and decision-making. The naturalized view dissolves some of the old boundaries between philosophy and science, by insisting that the best psychology of how we come to know things should inform our philosophical theories about knowledge. The strength of this approach is its humility. It recognizes that any account of knowledge is embedded in the mind's embodied processes and cultural practices. The danger, however, is that epistemology could be reduced to purely descriptive science, thereby risking the loss of normative criteria, questions about justification, truth, and rational belief that philosophers have long treated as central to knowledge. Across these lines, we can see how the conversation about empiricism remains lively and relevant in the 21st century. Contemporary debates about science, language, and mind draw directly on the old tensions between experience and the mind's shaping capacities. Consider examples from the practical world. In science, we often rely on mathematical models and computational tools whose success seems to depend on more than raw sensory data. In physics, for instance, theories about quantum fields live at a level of abstraction that looks suspiciously non-empirical in its day-to-day phenomenology, yet their predictive success forces us to take seriously an empiricist stance tempered by mathematical structure and theoretical insight. In cognitive science, we see how perception is not a transparent window to reality, but a construct built from sensory data and prior expectations, with Bayesian models showing how perception and belief are shaped by prior probabilities and new evidence. The same considerations show up in the philosophy of language, where the meaning of terms like see, know, or explain depends on a network of usage, context, and neural processes that are not reducible to simple sensory facts. The modern variants, constructive empiricism and naturalized epistemology, provide a way to speak to these concerns without surrendering the central empiricist insight that experience matters, and that science ultimately ties knowledge to something like the observable world. Yet we should not forget a simple, potent point. The empiricist program remains tremendously powerful as a disciplined method. It asks us to trace our beliefs to as reliable a source as possible, to test them against experience, to demand replicability, to value testable predictions, and to ground our theories in data that others can observe and critique. The empirical ideal is not a naive picture of knowledge as sensory passivity. It is a robust ideal that acknowledges the complexity of perception, the social character of science, and the mind's indispensable role in organizing experience. The late 20th century and early 21st century reformulations remind us of a crucial truth. The history of empiricism is not a straight line from sense data to true beliefs. It is a conversation through time about what counts as evidence, how to justify beliefs, and what the mind contributes to understanding. To bring this to life with concrete touchpoints, let us anchor the discussion with 2 or 3 vivid examples that straddle theory and practice. First, consider mathematics and logic as a test case for the empiricist insistence on sensory grounding. If our mathematical knowledge were to be derived solely from sensation, one might imagine that it would be vulnerable to contingencies of the senses, or perhaps to cultural differences in counting systems. Yet mathematics exhibits a universal and necessity-like quality that invites us to ask, what is the source of this apparent necessity? The Kantian suggestion is that mathematics arises, at least in part, from the mind's own forms of intuition, space, time, and the logical structure that governs how we connect concepts. This does not deprive mathematics of empirical significance. Rather, it reframes mathematical knowledge as an interface between the mind's a priori architecture and the rich fabric of sensory experience. The lesson for empiricism is not that mathematics cannot be known. It is that the route to understanding mathematical truth is not simply through sensory data, but through the mind's capacity to organize and synthesize those data according to structures that the mind itself supplies. Second, the perceptual and cognitive challenges. When we look at a line that appears longer than another because of the way it is drawn, or when we experience a color as different in different lighting, we are reminded of the mind's interpretive role. If experience were a transparent window into an independent world, such illusions would be surprises rather than natural. They are rather the daily proof that perception is a constructive act. Cognitive biases complicate the picture further. The human mind tends to favor evidence that aligns with prior beliefs, to anchor judgments on salient but limited data, and to infer causal connections even when statistics do not warrant them. These phenomena do not necessarily negate empiricism. They push us to refine our methods, to demand stronger evidence, to cultivate better experimental designs, and to appreciate the role of theory in guiding what counts as data. In modern science, these insights have given birth to methods like pre-registration, replication initiatives, and debates about evidential standards. The empirical project becomes a more exacting enterprise when we recognize that our cognitive architecture can mislead us, and yet we still trust experience as the anchor of rational inquiry. In sum, the journey from empiricism through its critics to its modern variants is a testament to a living tradition. We have seen how rationalist and innatist challenges press the claim that experience alone deserves every belief. We have seen Kant's critical synthesis offer a plausible way to honor both the primacy of experience and the indispensability of the mind's preconditions for experience. We have seen Quine's holism and his rejection of a clean analytic synthetic divide push us to rethink the way evidence supports theory. And we have glimpsed two historical episodes, the radical empiricism of Berkeley that challenges materialist metaphysics, and Kant's philosophical project that seeks to harmonize rationalist certainty with empirical grounding, that illuminate how the story of empiricism is, at heart, a story about the mind's capacity to make sense of a world we experience, a world that is never simply given to us as a set of unambiguous data. As we look toward contemporary variants, we glimpse the direction in which the conversation continues. Constructive empiricism refuses to pretend that science's aim is to reveal the world as it truly is independent of our descriptions. It asks us to value predictive success and observational adequacy as the proper achievements of science. Naturalized epistemology invites us to bring epistemology into the laboratory of psychology and neuroscience, to understand belief formation as a natural process, shaped by learning, memory, attention, and social interaction. In this light, the philosophy of empiricism becomes not a retreat from theory, but a sophisticated engagement with how human beings know, communicate, and decide in a world that challenges both our senses and our wits. Let us weave together the threads with a few concluding reflections. First, empiricism is not a denial of reason or a rejection of theory. It is an insistence that knowledge must be accountable to experience, that claims must be tested against what can be observed, and that our cognitive processes and theoretical structures must be honest about their role in shaping what we take to be true. Second, the critiques and alternatives we have explored do not merely complicate empiricism. They enrich it by clarifying what we expect from knowledge, how we ought to justify our beliefs, and what it would take to call a theory scientifically respectable or philosophically robust. Third, the tension between the primacy of experience and the mind's formative powers invites ongoing dialogue across disciplines, philosophy, science, psychology, linguistics, and cognitive neuroscience, so that we can better understand not only what we know, but how we come to know it and what we owe to the communities in which knowledge must be shared and defended. And as we move forward in the series, we will return to the core question that has guided this exploration. When we say we know something, what exactly do we mean by we? Do we mean our immediate sensory states? Do we mean a belief grounded in a robust chain of justification? Do we mean a theory that predicts, explains, and remains resilient in the face of new data? Or do we mean something more demanding still, the unity of experience across a wide array of domains, a harmony between what we measure and how we understand, a mind that is at once open to the world and structured to comprehend it? In the coming sections, we will continue to chart these questions with care, offering more concrete examples, more historical episodes, and more dialogue with thinkers who have challenged, sharpened, and expanded the empiricist project. We will revisit the major figures we've discussed: Locke, Berkeley, Hume, Descartes, Kant, Quine, and we will add new names and ideas to illuminate how modern science and philosophy continue to negotiate the balance between experience and mind. We will also look at how these discussions bear on practical matters, how we design experiments, how we interpret data, how language and mind interact in science and everyday life, and how our best theories stay robust in the face of changing evidence. The journey is long, but the path is illuminated by careful listening, careful arguing, and a steady reverence for the experience that makes knowledge possible, even as we recognize the mind's powerful role in shaping what we can know. To close this segment, I want to leave you with a few short, poignant reminders from primary voices that have shaped this conversation, not to close it, but to invite you into the living texture of the debate. From Descartes, the line that still rings with insistence on certainty in the face of doubt: "I think, therefore I am." From Berkeley, the radical inversion of matter into perception: esse percipi. From Kant, the claim that the mind constructs the experience it has of the world. The mind supplies the form of intuition, the categories of understanding, without which experience could not be experience at all. And from Quine, the reminder that our theory-laden web of belief must be tested against the entire fabric of experience, not merely a few isolated sentences. Our statements about the world face the tribunal of experience as a corporate body. As you reflect on these ideas, consider this question: when you next encounter a claim about the world, what counts as evidence for you, and where does the structure that makes that evidence intelligible come from? Is it a matter of the sensory data alone, steadily observed and replicated? Or does it also depend on the ways your mind organizes, categorizes, and interprets that data in ways that history, culture, and science continually refine? The answers are not simple, and they do not resolve themselves in a tidy, black and white fashion. They invite us to live with nuance, to test our beliefs against experience, to listen to dissenting voices within philosophy, and to keep an open mind about the possible ways that experience and mind co-create knowledge. In the next segment, we will explore more deeply the way science has negotiated these tensions in practice, how experiments are designed to minimize bias, how theories are evaluated against observation, and how debates about theory choice and scientific realism illuminate the ongoing dialogue between empiricism and rationalist intuition. We will also look at how language, meaning, and mind are studied in contemporary cognitive science and philosophy of language, to see how empirical methods illuminate questions about knowledge in a more precise and sometimes surprising way. The conversation continues, and the question remains: what counts as knowing, and how do we know it? The answer is never simply one thing. It is a living, evolving synthesis shaped by experience, reason, and the enduring curiosity that fuels inquiry itself. Empiricism today wears many faces, and the faces wear each other's features. In this section, we peer into the living texture of contemporary empiricism, not as a single doctrine, but as a family of approaches that share a reverence for experience, observation, and the careful weighing of evidence. We walk through the origins that still echo in laboratories and schools, then move toward ideas that are actively reshaping how we think, teach, and govern. The journey is not a retreat from theory into naked data, but a careful negotiation between what our senses report, how our concepts organize those reports, and how we calibrate belief in light of new information. We seek not simply to prove things right, but to understand how we come to know what we think we know, and how that knowledge persists, evolves, or proves fragile. To begin, let us revisit the roots that still cast their long shadows over modern empiricism. The early modern insistence that knowledge begins with experience, and that evidence gathered from the senses must ground belief, did not dispel theory, but rather sharpen the questions we ask of theory. Francis Bacon reminded us that knowledge is not an ornament for the mind, but a tool for practical life. Knowledge is power, he famously declared, and with that claim he placed observation and experiment at the center of the human quest to transform the world. Locke, writing in the thick of the empirical turn, insisted that the mind at birth is a tabula rasa, a blank slate, and that all ideas come to us through experience. No man's knowledge here can go beyond his experience, he writes, laying bare the boundary line between what is given in sensation and what mind makes of it through reflection, abstraction, and association. These sentences are not trivia, but invitations to see how empirical thinking becomes a living practice. Describe the object of inquiry, test your claims against experience, revise in light of what the world reveals, and do not mistake habit for inference. From these beginnings, a 20th century constellation emerged that would either sharpen or unsettle empiricism, depending on the angle you took. The logical positivists of the Vienna Circle argued for a rigorous link between meaning, verification, and experience. They proposed a criterion for meaningful discourse. The meaning of a statement lay in the method by which it could be verified or falsified through observation. A line from the Circle's philosophical air is compact and precise. The meaning of a proposition is its method of verification. If a claim cannot, even in principle, be tested by experience, it has no cognitive purchase within the scientific frame. This was not a merely technical claim about laboratory practice. It was a radical reconfiguration of what counts as knowledge and what counts as science. In the same era, Karl Popper offered a counterpoint that remains central to debates about empiricism. Science advances not by accumulating verified truths, but by formulating bold conjectures and subjecting them to ruthless falsification. A theory that cannot be tested in ways that could show it false, that is, a theory that is unfalsifiable, belongs outside the realm of genuine science, according to Popper's demarcation principle. Other voices pressed in from different directions. Willard Van Orman Quine challenged the very separation between analytic and synthetic knowledge, arguing that our interconnected web of beliefs is not neatly peeled apart into neat, a priori truths and empirical givens. Quine's image of the web of belief, where experiences, theories, and background assumptions support and revise one another, made room for empiricism without surrendering to naive foundationalist certainties. Ludwig Wittgenstein, confronting the limits of language, reminded us that the forms of our life shape what can be said and what must remain silent. In his later reflections, he invites us to notice how the everyday use of language constrains what can count as meaningful inquiry. The broad philosophical landscape thus emerges as a conversation. Empirical inquiry must contend with the stability of language, the social character of scientific communities, and the way theories become entrenched in the practices of normal science. Into this multi-voiced conversation, two modern developments offer particularly sharp tools for the contemporary era: constructive empiricism, championed by Bos van Fraassen, and Bayesian epistemology, a framework for updating beliefs in light of evidence. Constructive empiricism asks us to separate the aim of science from the aim of truth about unobservable entities. The central claim, stated with characteristic concision, is that the aim of science is empirical adequacy. The upshot is not a denial that unobservables exist, but a methodological stance. Science need not commit itself to the literal truth of unobservables. Instead, it should be judged by how well its theories account for observable phenomena. Van Fraassen's insistence, often summarized as a commitment to empirical adequacy while withholding metaphysical commitments about what lies behind the observable, reorients empirical inquiry toward the practical success of predictive and explanatory devices rather than its supposed correspondence to a hidden reality. When he writes, "The aim of science is empirical adequacy," he is signaling a disciplined humility before what we can witness and measure, and a willingness to treat unobservables as instruments of modeling rather than as established objects of belief. Bayesian epistemology, by contrast, treats evidence as a force that recalibrates belief in a precise, formal way. It does not deny that experience can be uncertain or noisy. Rather, it provides a calculus for how rational agents ought to adjust the degree of belief in competing hypotheses as new data arrive. The Bayesian dream is a picture of reasoning that remains coherent in the face of ambiguity. Prior beliefs encode what we think is plausible before seeing the data, and the likelihood of the data under each hypothesis tunes those beliefs after observation. When someone says that evidence updates beliefs by applying Bayes' rule, they are pointing to a principled method for combining what we already think with what the world is telling us through measurement, experiment, and observation. This is not a mere technical trick. It is a way of thinking about knowledge as a dynamic relation between evidence and belief, a steady process of revision rather than a single snapshot of certainty. To appreciate how these modern variants function in the wild, we turn to the realms of education, cognitive science, and public life, where empiricism is not an abstract posture but a living practice that shapes decisions, policies, and everyday actions. In education, empiricism translates into experiential learning and evidence-based pedagogy. The pedagogical turn toward experience treats knowledge as something students actively do rather than something poured into passive minds. Experiential learning, in the tradition of Kolb and others, emphasizes cycles of concrete experience, reflective observation, abstract conceptualization, and active experimentation. It is an empiricist's dream translated into the classroom. Hypotheses tested in real-world contexts, feedback loops that allow students to refine understanding, and attention to outcomes that can be measured, compared, and refined. Evidence-based pedagogy, meanwhile, asks for the systematic collection and analysis of educational outcomes, randomized controlled trials of teaching methods, meta-analyses of curriculum interventions, and the policy-inspired insistence that what works in the classroom should inform practice beyond anecdote and fashion. In this sense, empiricism becomes a cooperative enterprise between research and teaching, a bridge between laboratory-like studies of learning and the living moments when students encounter ideas in action. In cognitive science, the empiricist eye confronts perception, belief formation, and the mind's internal models of the world. Here the question is how external input becomes internal representation and how those representations drive action. The Bayesian brain hypothesis offers a coherent vocabulary. Perception is not a direct passive receipt of sensory data, but an active inference process in which the brain continually updates its best guess about the causes of sensory input. In perception, we are, in a sense, Bayesian artists painting with pixels of sensation, our prior expectations shaping what we see and feel. In belief formation, the same logic applies. Prior beliefs, shaped by prior experiences and learning, interact with the incoming stream of evidence to generate posterior beliefs. The empirical turn in cognitive science does not suppress theory. It reveals that theory is indispensable for understanding how evidence is interpreted. It uncovers constructive empiricism's prudence in the lab of the mind. Theories are tools for organizing experience, not mirrored spectacles of some untouched truth. Public life, too, has become, in many domains, a laboratory of empiricism. Data-driven policy is not merely about numbers. It is a philosophical stance that values transparency, testability, and iterative improvement. Open science movements and replicability efforts invite public scrutiny of methods and results, inviting a form of collective empirical governance where evidence is shared, methods are disclosed, and claims are subjected to independent verification. In medicine, evidence-based for practice has become a standard. Clinical decisions are anchored in the best available evidence while respecting patient values and clinical expertise. The patient's autonomy is recognized. Evidence remains a compass, not a tyrant. In policy, regulators and practitioners increasingly ask, what do the best available data show about a program's effectiveness? Does a policy achieve its stated goals, and at what cost? These questions are not merely technical. They reflect a normative conviction that our collective decisions should be justified by what the world allows us to learn from it, not simply by what political power or tradition demands. Two concrete episodes illuminate the contemporary empiricist project from opposite ends of the spectrum. The first is the replication crisis in psychology and the Open Science Collaboration's 2015 project. In this milestone, researchers attempted to replicate a large sample of classic findings from psychology. The result was sobering. A substantial portion of discovered effects failed to replicate under more rigorous procedures, and the overall replication rate raised questions about how confidently we could generalize findings from single studies to broader theory. The report did not deny the value of earlier work. It reframed it, pointing to the need for pre-registration, transparent data sharing, and methodological discipline. As one participant in the broader conversation has put it, the replication effort reveals that science, even when well-motivated and diligent, is not a flawless factory of truth, but a human practice susceptible to biases, noise, and quirks of experimental design. The Open Science Collaboration's 2015 project, documented in Science with a headline that many remember, pushed the scientific community to take seriously questions about reliability, robustness, and the long arc of cumulative knowledge. It is, in Van Frossen's vocabulary, a reminder that empirical adequacy is not a passport to careless inference, but a call to sustain methods that increasingly guarantee that observable predictions behave well across contexts. The second episode concerns the rise of data-driven policymaking and evidence-based medicine. In governance and healthcare, the demand for decisions grounded in data has intensified, in part as a response to earlier overreach or intuition-driven policies that produced unintended consequences. In medicine, Sackett and colleagues defined evidence-based practice as the conscientious, explicit, and judicious use of the current best evidence in making decisions about the care of individual patients, balancing it with clinical expertise and patient preferences. This formulation does not pretend that data will deliver perfect answers, but it treats data as a central instrument for aligning care with what works best in practice. In public policy, the shift toward evaluating programs through randomized trials, natural experiments, and robust statistical analyses reflects a Bayesian sensibility in spirit. Prior assumptions about what works are updated in light of systematic observations, and policies are refined as new data arrive. The goal is not certainty in the universal sense, but a defensible trajectory of improvement, with humility about what remains unknown and a readiness to revise. As we navigate these developments, it is crucial to register two enduring counterarguments to strict empiricism in this contemporary frame. The first is that data can be noisy, biased, or spurious. No matter how sophisticated our instruments or how large our samples, measurement error, sampling bias, publication bias, p-hacking, and model misspecification can produce patterns that look meaningful but do not generalize. The replication project's sobering returns are a reminder that data, while indispensable, require careful design, pre-registration, and a healthy skepticism about surprising or spectacular findings. The Bayesian approach helps here by formalizing the uncertainty around data and by insisting that we treat prior knowledge as an active partner in interpretation, not a stubborn overlay to be discarded. Yet Bayes cannot solve the problem of biased priors or manipulative data. It can only make transparent how such factors influence belief updates. For a strict empiricist, this is a challenge. Data alone do not speak for themselves. Their interpretation depends on the frameworks, methods, and communities by which they are gathered and evaluated. The second major counterargument is that theory-ladenness persists despite data abundance. The idea that observation and measurement are never theory-free cuts through the romance of data as a neutral repository of facts. Theory-ladenness means that what we decide to observe, how we categorize phenomena, what counts as a relevant variable, and which questions we deem legitimate are all shaped by prior theoretical commitments. This insight, associated with philosophers like Kuhn and later developments in phenomenology and science studies, suggests that even an empiricist program cannot escape the pressures of conceptual frameworks, disciplinary norms, and value-laden priorities. We may be tempted to think that a flood of data will settle the matter, but the data are filtered, organized, and interpreted through scientific habits that themselves are historically and culturally situated. The replication movement has, in effect, made visible a social and epistemic ecosystem. Researchers, journals, funding bodies, and peer communities all influence what counts as credible evidence and how vigorously claims are tested. The challenge is to preserve objectivity and reliability without erasing context, interpretation, and the human elements that shape inquiry. These two counterarguments, noise and bias in data, and the stubborn persistence of theory through observation, do not undermine empiricism. They refine it. They demand epistemic virtue, humility about what data can and cannot prove, clarity about methods, openness to correction, and an iterative temperament that treats knowledge as provisional rather than final. They invite a more sophisticated empiricism, in which constructive empiricism and Bayesian reasoning are not incompatible with critical scrutiny of data, and with explicit attention to the theoretical scaffolds that give data meaning. In this sense, contemporary empiricism is not a blind faith in measurement. It is a disciplined, evolving practice that marries the best available methods with a candid awareness of their limits. If we pause to reflect on the arc of these developments, two historical anecdotes illuminate the shift in how we think about evidence and explanation. The first takes us to the emergence of logical positivism in the early 20th century. The Vienna Circle, with its commitment to verifiability and its insistence that meaningful statements must be tethered to experience, framed science as a disciplined enterprise whose legitimacy rested on testable propositions. The verifiability principle carried with it a conviction about the demarcation between what can be meaningfully discussed and what should be left aside as meaningless metaphysics. The appeal of this stance lay in its clarity and its courage to subject claims to the tribunal of experience. Yet the same movement also opened space for critique from later philosophers who argued that meaning cannot be reduced to verification alone, and that science is not a mere ledger of observable data, but a social and historical project with its own internal debates, biases, and power structures. The positivist moment thus becomes a hinge. It marks the moment when empiricism claimed a central place in philosophy and science, while also becoming a site where later thinkers would challenge, revise, or reconceptualize that claim. The second anecdote concerns the modern replication and reproducibility movements. The claim that science is self-correcting rests on the ideal of replicability, and yet the contemporary landscape reveals the fragility of that ideal in practice. The replication crisis did not start as a radical break, but as a gradual recognition that findings, especially in psychology and social science, are often contingent on specific conditions, researcher degrees of freedom, and publication pressures. When the Open Science Collaboration published its 2015 project, revealing that a substantial portion of studied effects did not replicate, the field faced a crucible. It did not condemn previous work as worthless. It urged a culture of openness, pre-registration, data sharing, and rigorous methodological standards. The crisis is a reminder that empirical inquiry thrives on transparency, and that the value of evidence is measured not only by what it demonstrates in a single study, but by how robust, replicable, and cumulative it proves to be across time and contexts. A more recent anecdote concerns the cognitive biases that shape everyday decision-making, even in the face of abundant data. It is not merely that humans are error-prone. It is that their reasoning often uses cognitive shortcuts, heuristics that are efficient but biased. In daily life, Bayesian updating is the ideal, but actual reasoning frequently deviates. The classic experiments in judgment under uncertainty show that people rely on availability, anchoring, and representativeness rather than strict probabilistic calculation, and that these patterns persist even when the stakes are real and the data plentiful. These observations do not undercut empiricism. They illuminate the psychology of belief formation, how prior expectations, social influences, and cognitive architecture shape what counts as evidence in the mind. They invite us to design better educational tools, better policies, and better scientific practices that acknowledge human limits while still aiming for rational, evidence-based inquiry. In weaving together these threads, the two modern variants, the concrete applications, the concrete episodes, the counterarguments, and the historical anecdotes, we encounter a broader intellectual ecology. Constructive empiricism and Bayesian epistemology are not isolated doctrines. They are part of a long conversation that includes Popper's insistence on testability, Kuhn's reflections on paradigm shifts, Feyerabend's provocations about methodological pluralism, Quine's holistic critique of the analytic-synthetic distinction, Wittgenstein's caution about language, and phenomenology's insistence on the primacy of lived experience and intentionality. Each of these voices contributes to a richer sense of how empiricism travels through time, not as a monolithic creed, but as a living practice that invites critique, adaptation, and renewal. If the empiricist project in the modern world has a guiding posture, it is this: be rigorous about evidence, be transparent about methods, be skeptical about overreach, and be open to revision in light of better data and better theories. The practical reverberations of this contemporary empiricism reach far beyond the walls of laboratories and lecture halls. In education, the shift toward experiential learning and evidence-based pedagogy has the potential to democratize knowledge in meaningful ways, offering students opportunities to test ideas in authentic contexts and to see how abstract principles hold up when confronted with real-world complexity. It invites educators to measure outcomes not only in test scores, but in the growth of critical thinking, problem-solving, collaboration, and adaptive learning. The aim is not programmatic compliance with the latest research, but a living practice of teaching that can be evaluated, revised, and improved through careful observation and dialogue with learners. In cognitive science, the empirical turn helps illuminate the mechanics of perception and belief formation without reducing us to passive data processors. It suggests that the mind is an active inference engine, constantly measuring, predicting, and adjusting its model of the world. This view has profound implications for education, where learners are not empty vessels to be filled with facts, but agents constructing models, testing predictions, and refining their understanding through feedback. It also bears on public discourse, how we interpret media, how we evaluate competing claims, how we calibrate risk and uncertainty in a world of rapid information flows. The Bayesian perspective offers a language for discussing uncertainty without surrendering to cynicism. It invites reasoned, disciplined updating rather than alarmed rigidity or blind faith. In public life, data-driven policy and open science promise a more accountable and responsive governance. When policy decisions are evaluated against pre-registered hypotheses, explicit metrics, and accessible data, the public gains a clearer view of what works, what does not, and why. The open science movement's push for pre-registration, data sharing, and replication makes science a participatory enterprise in which the boundaries between researchers and citizens blur in the service of reliability. And in medicine, evidence-based practice anchors patient care in systematic reviews, randomized trials, and carefully weighed guidelines, recognizing that evidence alone does not determine action, but that it should strongly inform judgment when it is integrated with clinical expertise and patient values. Yet across these domains, we must hold in tension two truths. First, empiricism is not a guarantee of infallibility. Even as we refine methods, we must remain alert to errors, biases, and misinterpretations. The replication crisis was not a verdict on science as such, but a prompt to strengthen cultural and methodological norms, more pre-registration, more transparent data, more robust statistical practices, and more humility about what any single study can prove. Second, empiricism must engage with theory, not simply replace theory with data. The stories we tell about how the world works, the questions we ask, and the models we build are all about theory shaping data as much as data shaping theory. The practice of science is a dialogue between data and theory, between method and meaning, between evidence and the broader aims of human inquiry. If we are to follow the path laid out by these developments, we can see how the tradition of empiricism remains dynamic rather than static. Constructive empiricism reminds us to value the observable and to reserve metaphysical commitments about unobservables for another time and place. Bayesian epistemology reminds us that belief is always hypothesis in motion, shaped by how we weigh new information against what we already hold to be probable. These are not contradictory visions, but complementary ones, each offering a guardrail against both credulity and cynicism. The practical upshot for the curious learner, the patient teacher, the responsible policymaker, and the thoughtful citizen is a disciplined openness to evidence, to revision, to dialogue, and to the possibility that what seems true today may be enlarged, corrected, or redirected by the discoveries of tomorrow. In closing, consider how this contemporary empiricism invites us to cross from the laboratory into the street, from abstract discussions of theory into tangible acts of understanding and responsibility. The aim is not to abandon philosophy for mathematics or for data points, but to harness both in a way that respects the complexity of experience. We should acknowledge that the history of empiricism is also the history of human fallibility and ingenuity. The early insistence on observation and experiment, the mid-century debates about the meanings and limits of science, and the present-day experiments in replication, transparency, and predictive modeling. We should listen to the voices of Popper and Kuhn, who remind us that science advances by bold conjecture and critical testing, and we should hear from Quine and Wittgenstein that our linguistic and conceptual frameworks both enable and constrain what counts as evidence. We should also learn from phenomenology's insistence that experience has a first-person texture that cannot be entirely subsumed under third-person measurements, and from the pragmatist insight that truth is a living fruit of inquiry, useful, workable, and revisable. And so the contemporary variations and applications of empiricism become not a retreat from wonder, but an invitation to a more deliberate, more collaborative, and more humane form of inquiry. We are called to nurture a culture in which experiential data are collected with care, analyzed with transparency, and used to inform decisions that affect real lives. Where perception, belief, and action are understood as interconnected processes governed by rational updating and responsible judgment. Where education, science, and policy are organized to learn from error as a path to improvement. In the end, empiricism persists not as a finished doctrine, but as a living practice, an ongoing conversation about how we know, how we test what we think we know, and how we choose to live with the best available understanding of the world as we experience it together.